Hello everyone. So this course is all about Azure DevOps, which is known as AZ-400. If you are planning to sit for this certification, please make sure that you are at least certified on Azure Administrator or Azure Developer. Azure Administrator is AZ-104 and Azure Developer is AZ-204. This is one of the prerequisites for this AZ-400 certification. In this course, I tried my level best to explain all the concepts you need to understand for AZ-400 certification. And I will make sure to put the timestamp on all the topic I discussed right below the like button so it is easier for you to navigate between these topics. I hope you find this course useful and I wish you all the very best for your examination. The DevOps certification exam is for DevOps professionals who combine people, process, and technologies to continuously deliver valuable products and services that meet end users' need and business objectives. DevOps professionals are the one who design and implement strategies for application code and infrastructure that allow for continuous integration, continuous testing, continuous delivery, and continuous monitoring and feedback. And this AZ-400 examination candidates must be proficient with agile practices. They must be familiar with both Azure administration and Azure development and expert in at least one of these areas. Azure DevOps professionals must be able to design and implement DevOps practices for version control, compliance, infrastructure as a code, configuration management, build, release, and testing. And based on the study area, I have prepared this tutorial and created 20 different modules to explain all the concepts which Microsoft wants you to learn based on the study area. I'm not going to read out each one by one, but you can see on my screen, I will take you through each and every module which explain all the topics what I have mentioned here. And this course provides the knowledge and skills to design and implement DevOps processes and practices. And you will be able to learn how to plan for DevOps, use source control, scale Git for an enterprise, consolidate artifacts, design a dependency management strategy, manage secrets, implement continuous integration, and implement a container build strategy, design a release strategy, and set up a release management workflow, implement a deployment pattern, and optimize feedback mechanisms. You need to have a fundamental knowledge about Azure, version control, agile software development, and core software development principles before studying this examination. It would be helpful to have an experience in an organization that delivers software as well. The first set of videos in this tutorial is all going to be lecture based. So what do I mean by lecture based? Lecture based means it's theoretical knowledge on all the concepts and core fundamentals. In the meantime, if you want to get the hands on, you can create a free Azure subscription and you can sign up for a free Azure DevOps account and you can sign into Azure DevOps Demo Generator to perform your own labs as well. Like I said, if you want to download this material, you can go to aguidetocloud.com to download this study guide, which will have all the links mentioned here. Since this is AZ-400 certification exam and it's an expert level certification exam, it's safe to assume that you guys know how to sit for a Microsoft certification examination because you would have already done multiple examinations. And if it has been quite a while, I can give you a quick refresher. On this examination, you can expect questions between 40 to 60, and there is no penalty for guessing. That means that you need to answer all the questions. Otherwise, you are missing out an opportunity to earn points from each questions. Always prepare for answering the question and put up some time for reviewing and making sure that you're going through commenting, reporting, etc. Because this is an expert level exam, you can expect more than multiple choice questions. There are going to be hot areas, active screen, drag and drop, match the following, and case studies as well. And in most instances, there are going to be lab scenarios as well. So please do get your hands on with Azure DevOps Labs as well. All right, so that concludes the first episode. In this episode, we're going to learn about what is DevOps. So what is DevOps? DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. The contraction of dev and ops refers to replacing siloed development and operations to create multidisciplinary teams that now work together with shared and efficient practices and tools. Essential DevOps practices include agile planning, continuous integration, continuous delivery, and monitoring of applications. And DevOps is a continuous journey. Let's start with a basic assumption about software development. I will describe it with OODA, which is observe, orient, decide, and act loop. This is originally designed to keep fighter pilots from being shot out of the sky. The OODA loop is a good way to think about staying ahead of your competitors. You start with observation of business, market, needs, current user behavior, and available telemetry data. Then you orient this data with enumeration of options for what you can deliver, perhaps with experiments. Next, you decide what to pursue, and you act by delivering working software to real users. All of this occurs in some cycle time. Hopefully, you use data to inform what to do in the next cycle. Many experience tell us that roughly one third of the deployment will have a negative business results. Roughly one third will have positive results, and one third will make no difference. Ideally, you would like to fail fast on those that don't advance the business and double down on those that support the business. Sometimes this is called pivot or persevere. So let's learn how you can strive for validated learning. How quickly you can fail fast or double down is determined by how long that loop takes, or in lean terms, by your cycle time. Your cycle time determines how quickly you can gather feedback to determine what happens in the next loop. The feedback that you gather with each cycle should be real, actionable data. This is called validated learning. So, how can you shorten your cycle time? When you adopt DevOps practices, you shorten your cycle time by working in smaller batches, using more automation, hardening your release pipeline, improving your telemetry, and deploying more frequently. The more frequently you deploy, the more you can experiment, the more opportunity you have to pivot or persevere, and to gain validated learning each cycle. This acceleration is validated learning in the value of improvement. Think of it as the sum of improvements that you achieve and the failures that you avoid. Now let us understand how this DevOps journey looks like. The first step is continuous integration, which drives the ongoing merging and testing of code, which leads to finding defects early. Other benefits include less time wasted on fighting merge issues and rapid feedback for development teams. Second step is continuous delivery of software solutions to production and testing environment helps organization quickly fix bugs and respond to ever-changing business requirements. Third step is version control. Usually with Git enables teams located anywhere in the world to communicate effectively during daily development activities as well as to integrate with software development tools for monitoring activities such as deployments. Step number 4 is all about agile planning. Agile planning and learn project management techniques are used to plan and isolate work into sprints and manage teams' capacity and helps teams quickly adapt to changing business needs. A DevOps definition of done is working software collecting telemetry against the intended business objectives. Step number 5, it's all about monitoring and logging. This is where you monitor and log the running applications, including production environments, for application health as well as customer usage. This helps organizations form a hypothesis and quickly validate or disprove strategies. Rich data is captured and stored in various logging formats in this stage. Public and hybrid cloud have made the impossible easy. The cloud has removed traditional bottlenecks and helped commoditize infrastructure. Whether you use infrastructure as a service to lift and shift your existing apps or platform as a service to gain unprecedented productivity, the cloud gives you a data center without limits. Let's talk about IaaC, which is infrastructure as code. Infrastructure as code is a practice which enables the automation and validation of creation and tear down of environments to help with delivering secure and stable application hosting platforms. Step number 8 is all about microservices architecture. Microservice architecture is leveraged to isolate business use cases into small, reusable services that communicate via interface contracts. This architecture enables scalability and efficiency, and containers are the next evolution in virtualization. They are much more lightweight than virtual machines. This allows much faster hydration and can be easily configured from files. So if DevOps hurts, do it more often. Just like going to the gym, adopting new practices is likely to hurt at first. The more often you exercise the new practices, the easier they will become. And just like training at the gym, where you exercise large muscles before the small muscles, adopt practices that have the greatest impact first and cross train to develop synergy. So that concludes our first lesson. In this episode, we're going to learn about how can you plan for DevOps. Let's start with understanding how can you separate transformation teams. Unless you're building an entirely new organization, one of the big challenges with any development transformation project is that you will be taking actions that conflict at least in some way with ongoing business states. There are many aspects to this. The first challenge is the availability of staff. If the staff members who were leading the transformation project are not involved in existing day-to-day work within the organization, it will be difficult for them to focus on the transformation, particularly if their existing role directly impacts customer outcomes. We all know that the desperate situation that involves customer will always win over a long-term project like DevOps transformations. Another issue will be the way that the organization currently operates. Existing processes and procedures have been implemented to support current business outcomes. The disruption that is required for a true DevOps transformation will usually end up challenging those existing processes and procedures. Doing that is often very difficult. Dr. Vijay Govindarajan and Dr. Chris Trimble, in their books Beyond the Idea, How to Execute Innovation, has researched what's involved in allowing innovation to occur in organization and noted that when this is successful, it's often been in spite of existing organizational processes. They concluded that it only works where a separate team is created to pursue the transformation. For DevOps transformations, the separate team should be made of staff members, all of whom are focused on and measured on the transformation outcomes and not involved in the operational day-to-day work. The team might also include some external experts that can fill in the gaps and help to advise on processes that are new to the existing staff members. Ideally, the staff members who were recruited for this should already be well regarded throughout the organization, and as a group, they should offer a broad knowledge base so they can think outside of the box. So, how can you define shared goals? Most management courses would tell you that if you want to change something, you need to make sure that it's measurable. DevOps transformations are no different. The project needs to have a clearly defined set of measurable outcomes. The outcome should include specific measurable targets like reduce the time spent on fixing bugs by 60%, reduce the time spent on unplanned work by 70%, reduce the out of hours work required by staff to no more than 10% of total working time, remove all direct patching of production systems, etc. Please note that one of the key aims of DevOps is to provide greater customer value, so outcomes should have a customer value focus. Let's understand how you can set up timelines for your goals. Measurable goals also need to have timelines. While it's easy to set long-term goals, it's also easy to put off work when you know it's not needed for a while. While overall projects should have timelines that span anywhere from a few months to a year or two in any DevOps transformation project, It's important to have a constant series of short term goals. Every few weeks, the improvement made should be clear and measurable, and ideally also observes the organization and or its customers. Clearly, the timeline should not be too short. They should always be challenging yet achievable. A review should occur after each short term goal to assist in planning the next one. There are several advantages of the shorter timelines. One key advantage is that it's easier to change plans or priorities when necessary. Another is that the reduced delay between doing work and getting feedback helps to ensure that the learnings and the feedbacks are incorporated quickly. Finally, it's easier to keep organizational support when positive outcomes are apparent. That concludes this lesson. In this episode, we're going to learn about DevOps project selection. This includes understanding greenfield and brownfield projects. The terms greenfield and brownfield have their origins in residential and industrial building projects. A greenfield project is one done on a greenfield, that is, undeveloped land. A brownfield project is one that was done on a land that was previously used for other purposes. Because of the land use that has previously occurred, there could be challenges with reusing the land. Some of these would be obvious, like existing buildings, but could also be less obvious, like polluted soil, etc. The same terms are routinely applied to software projects and commonly used to describe DevOps projects. On the surface, it can seem that greenfield DevOps project would be easier to manage and to achieve success. There was no existing code base, no existing team dynamics of politics, and possibly no existing rigid processes. Because of this, there is a common misconception that DevOps is really only for greenfield projects and that it suits startups best. However, a large number of very successful brownfield DevOps projects have occurred. The beauty of this project is there is often already a large gap between the customer expectation and what is being delivered. And the teams involved may very well realize the status quo needs to change because they have lived the challenges and the limitations associated with what they are currently doing. So let's understand how you can choose greenfield and brownfield projects. When starting a DevOps transformation, you might need to choose between greenfield and brownfield projects. So let's understand how you can choose between greenfield and brownfield projects. A greenfield project will always appear to be easier starting point because a blank slate offers the chance to implement everything the way that they want. You might also have a better chance of avoiding existing business processes that do not align with your project plans. For example, if current IT policies do not allow the use of cloud-based infrastructure, this might be allowed for entirely new applications that are designed for that environment from scratch. As another example, you might be able to sidestep internal political issues that are well entrenched. So, how can you choose brownfield projects? While brownfield projects come with the baggage of existing code bases, existing teams, and often a great amount of technical debt, they can still be ideal projects for DevOps transformations. When your teams are spending large percentage of their time just maintaining the existing brownfield application, you have limited ability to work on new code. It's important to find a way to reduce that time and to make software releases less risky. A DevOps transformation can provide that. The existing team members will often have been worn down by the limitation of how they have been working in the past and be keen to try to experiment with new ideas. There are often systems that the organizations will be currently depending upon, so it might also be easier to gain stronger management buy-in for these projects because of the size of the potential benefit that could be derived. And management might also have a stronger sense of urgency to point brownfield projects in an appropriate direction when compared to a greenfield project that don't currently exist. Eventually, the goal will be to evolve your entire organization. In looking to take the first step, Many organizations start with a greenfield project and then move on from there. When selecting systems and candidates for starting a DevOps transformation, it's important to consider the types of system that you operate. Some researchers suggest that organizations often use bimodal IT, a practice of managing two separate coherent modes of IT delivery, one focused on stability and predictability, and the other on agility. So let's understand what is systems of record. Systems that are considered to be providing the truth about data elements are most often called as systems of record. These systems have historically evolved slowly and carefully. For example, it is crucial that a banking system accurately reflects your bank balance. Systems of record emphasize accuracy and security. So, what is systems of engagement? And how can you choose systems of engagement? Many organizations have other systems that are more exploratory. These often use experimentation to solve new problems. Systems of engagement are ones that are modified regularly. Making changes quickly is prioritized over ensuring that the changes are right. There is a perception that DevOps suit systems of engagement more than systems of record. But the lesson from high-performing companies show that this is just isn't the case. Sometimes the criticality of doing things right with the systems of record is an excuse for not implementing DevOps practices. Worse, given the way that applications are interconnected, an issue in a system of engagement might end up causing a problem in a system of record anyway. Both types of systems are important. When first starting a DevOps transformation, DevOps practices apply to both types of systems. The most significant outcomes often come from transforming systems of record. So let's understand how can you select groups to minimize initial resistance. Not all staff members within an organization will be receptive to the change that is required for a DevOps transformation. In discussions around continuous delivery, users are often categorized into three general buckets: canaries, early adopters, and users. Canaries are who voluntarily test bleeding edge features as soon as they are available. Early adopters who voluntarily preview releases considered more refined than the code that canary users are exposed to. Users are who consume the product after passing through canaries and early adopters. While development and IT operations staff might generally be expected to be less conservative than users, their attitude will also range from very conservative to early adopters, and to those happy to work at the innovation's edge. Let's look at some of the ideal scenarios. For a successful DevOps transformation, the aim is to find team members that with following characteristics: they already think they are in a need to change, they have previously shown an ability to innovate, they are already well respected within the organization, and they have a broad knowledge of the organization and how it operates, and ideally they already believe that DevOps practices are what is needed. So let's discuss ideal target improvements. It is also important to roll out changes incrementally. There is an old saying in the industry that any successful large IT systems was previously a successful small IT system. Large-scale systems that are rolled out all at once have a very poor record of success. Most fail no matter how much support management has provided. When starting, it is important to find an improvement goal that can be used to gain early wins and is small enough to be achievable in a reasonable time frame and has benefits that are significant enough to be obvious to the organization. This allows constant learning from rapid feedback and the ability to recover from mistakes quickly. Please note that the aim is to build a snowball effect where each new successful outcomes adds to previous successful outcomes. This will maximize the buy-in from all those are affected. Let's identify project metrics and KPIs. I spoke earlier about the importance of shared goals. As well as being agreed by team members, the goal needed to be specific, measurable, and time bound. To ensure that these goals are measurable, it is important to establish and agree upon appropriate metrics and key performance indicators. While there is no specific list of metrics and KPIs that apply to all DevOps projects, let's discuss some of the commonly used metrics and KPIs. Let's start with understanding the faster outcomes. The first one is deployment frequency. Increasing the frequency of deployments is often a critical driver in DevOps projects. Another metric is deployment speed. As well as increasing how often deployments happen, it's important to decrease the time that they take. The third metric is deployment size. How many features, stories, and bug fixes are being deployed each time? And finally, lead time. How long does it take from starting on a work item until it is deployed? Another metric or KPI is efficiency. The first one we are going to look into is called server to admin ratio. Are the projects reducing the number of administrators required for a given number of servers? Another metric is staff members to customers ratio. Is it possible for less staff members to serve a given number of customers? Third is application usage. How busy is the application? And the fourth metric is application performance. Is the application performance improving or dropping based on the application metrics? Let's look at other KPIs. This time it's quality and security. This is where first you will discuss deployment failure rates. How often do deployments and or applications fail? Second is application failure rate. How often do application failures occur, and such as configuration failures, performance timeout, etc. Mean time to recover is where you will ask like how quickly can you recover from a failure. Another one is bug report rates. This is where you will ask, you don't want customers finding bugs in your code. Is the amount they are finding increasing or decreasing? Another metric is test pass rates. How well it is your automated testing working? Another stage is defect escape rate. What percentage of defects are being found in production? And the availability is what percentage of time is the application truly available for customers? And SLA achievement is where you will ask, are you meeting your service level agreements? And finally, mean time for detection is where you are going to ask, if there is a failure, how long does it take for it to be detected? Finally, it boils down to culture. First key metric to measure is employee morale. Are employees happy with the transformation and where the organization is heading? Are they still willing to respond to further changes? This can be very difficult to measure, but is often done by periodic, anonymous employee surveys. Another key metric to observe is retention rates. Is the organization losing staff? Please note that it is important to choose metrics that focuses on specific business outcomes and that achieve a return on investment and increased business value. That concludes this lesson. In this episode, we are going to learn about DevOps team structures. And in this lesson, we are going to learn about waterfall and agile development practices. Let's start with understanding what is waterfall development practice. Traditional software development practice involve determining a problem to be solved, analyzing the requirements, building and testing the required code, and then delivering the outcome to users. This is often referred to as a waterfall approach. The waterfall model follows a sequential order. A project development team only moves to the next step of the development or testing if the previous step is completed successfully. It's what an engineer would do when building a bridge or a building. So it might seem appropriate for software projects as well. However, the waterfall methodology has some drawbacks. One in particular relates to a customer requirements. Even a customer requirements are defined very accurately at the start of a project. Because these projects often take long time, by delivery, the outcome may no longer match what the customer needs. There is a real challenge with the gathering of customer requirements in the first place. Even if you build exactly what the customer asks for, it will often be different to what they need. Customers often don't know what they want until they see it or are unable to articulate what they need. Now let's compare the waterfall model with an agile development practices. By comparison, agile methodology emphasizes constantly adaptive planning and early delivery with continual improvement. Rather than restricting development to rigid specifications, it encourages rapid and flexible responses to change as they occur. In 2001, a group of highly regarded developers published a manifesto for agile software development. They said that development need to favor individuals and interactions over processes and tools. Working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to changes over following a plan. Agile software development models are based on releasing and iterations. One release might consist of several iterations. Each iteration is similar to very small independent project, and after being estimated and prioritized, features, bug fixes, and enhancements are and refactoring width is assigned to a release and then assigned again to a specific iteration within the release, generally on a priority basis. At the end of each iteration, they should be tested working code. In each iteration, the team must focus on outcomes of the previous iteration and learn from that. An advantage of having teams focus on shorter term outcomes is that teams are also less likely to waste time over engineering features or allowing an unnecessary scope creep to occur. Agile software development helps teams keep focused on business outcomes. Let's look at the comparison of a waterfall and an agile methodologies. Compared to the waterfall model, agile model separates the project development lifecycle into sprints. Waterfall model could be rigid, and agile model is known for its flexibility. In waterfall, all project development phases such as design, development, and test are completed all at once. Where in agile it follows an iterative development approach, so each phase may appear more than once. Within waterfall model, you define requirement at start of the project with little change to be expected. Where in agile methodology, requirements are expected to change and evolve. In waterfall model, you focus on completing the project, and in the agile model, you focus on meeting customer demands. Let's discuss the principles of agile development. The Agile Alliance says that its mission is to support people who explore and apply agile values, principles, and practices to make building software solutions more effective, humane, and sustainable. They have published a manifesto for agile software development. From that, they have distilled the 12 principles behind the Agile Manifesto. Let me discuss these one by one. The first principle is our highest priority is to satisfy the customer through early and continuous delivery of valuable software. Second principle is welcome changing requirements even late in development. Agile processes harness change for the customer's competitive advantage. Third principle is to deliver working software frequently, from a couple of weeks to a couple of months, with a preference to the shorter timeline. Fourth principle is all around business people and developers must work together daily throughout the project. Fifth principle is build projects around motivated individuals. Give them the environment and support they need and trust them to get the job done. Sixth principle is the most efficient and effective method of conveying information to and within a development team is to have a face-to-face conversation. Seventh principle is all around working software is primarily measure of progress. Eighth principle is agile processes promote sustainable development. The sponsors, the developers, and users should be able to maintain a constant pace indefinitely. Ninth principle is continuous attention to technical excellence, and a good design enhances agility. Tenth principle is simplicity. The art of maximizing the amount of work not done is essential. 11th principle is the best architectures, requirements, and designs emerge from self-organizing teams. And the last principle is at regular intervals, the team reflects on how to become more effective and then tunes and adjusts its behavior accordingly. Now let's understand how can you create organization structure for agile practices. For most organizations, recognizing to be agile is very difficult. It requires a mind shift and culture shift that challenges many existing policies and processes within the organization. This isn't surprising because good governance in organizations, particularly in large organizations, often end up leading to a large number of quite rigid rules, operating structures, and methods. It also tends to avoid wide delegation of authority. While most large organizations haven't moved to an agile structure, most are now experimenting with doing so. Their business environments are volatile and complex, and they have seen the limitation of their current structures, particularly in regard to an inability to cope with change fast enough. They realize that it is common today for long term established businesses and their industries to be disrupted by startups. So let's look at horizontal versus vertical team. Traditionally, horizontal team structures divide teams according to software architecture. In this example, the teams have been divided into user interface, service oriented architecture, and data terms. What about vertical team structures? By comparison, vertical team structures span the architecture and are aligned with skill sets or disciplines. And vertical teams have been shown to provide stronger outcomes in agile projects. It's important that each product has a clearly identified owner. Another key benefit of the vertical team structure is that scaling can occur by adding teams. In this example, feature teams have been created rather than just project teams. So let's look into how can you mentor team members on agile practices. While it's desirable to have formal agile training for staff members, no matter how good any agile course is, there is a world of difference between learning a concept within a few days and putting it into practice. When they first start an agile transformation, many teams hire external coaches and mentors. Agile coaches help teams or individuals to adopt agile methodologies or to improve the current methods and practices. They must be agent of change by helping people to understand how they work and encourage them to adopt new methods. Agile coaches typically work with more than one team and try to remove any roadblocks from inside or outside the organization. This work requires a variety of skills including coaching, mentoring, teaching, and facilitating. Agile coaches must be both trainers and consultants. There is more than one type of agile coach. Some coaches are technical experts who aim to show staff members how to apply specific concepts like test-driven development and implementation of continuous integration or deployment. These coaches might perform peer programming sessions with staff members. Other coaches are focused on agile processes, determining requirements, and managing work activities. They might assist in how to run effective stand up and review meetings. Some coaches may themselves act as scrum masters. They might mentor staff in how to fill these roles. Over time, though, it's important for team members to develop an ability to mentor each other. Teams should aim to be self organizing. And team members are often expected to learn as they work and to acquire skill from each other. To make this effective, though, the work itself needs to be done in a collaborative way, not by individuals working by themselves. Let's understand how can you enable in-team and cross-team collaboration. Effective collaboration is critical for well-functioning agile teams. Enabling this requires both cultural changes, cross-functional team collaboration, and tooling. So, what is cultural changes? Over recent decades, offices have often become open spaces with few walls. Ironically, this can limit collaboration, and ambient noise and distractions often also reduce productivity. Staff tend to work better when they have quiet, comfortable working environments. Define meeting times and locations. Let staff choose when they want to interact with others. Asynchronous communication should be encouraged, but there should not be an expectation that all communication will be responded to urgently. Staff should be able to focus on their primary task without feeling like they've been left out of important discussions. All meetings should have strict time frames and, more importantly, have an agenda. If there is no agenda, there should be no meeting. As it is becoming harder to find the required staff, great teams will be just as comfortable with remote or work from home workers as they are for those in the office. To make this successful, though, collaboration via communication should be part of the organization's DNA. And staff should be encouraged to communicate openly and frankly. Learning to deal with conflict is important for any team, as there will be disagreements at some point. Another way to improve the collaboration is by using cross functional teams. It is clear that members of a team need to have a good collaboration. It is also important to have a great collaboration with a wider team to bring people with different functional expertise together to work towards a common goal. Often, these will be people from different departments within an organization. Faster and better innovation can occur in those cross functional teams. People from different areas of the organizations will have different views of the same problem, and they are more likely to come up with alternative solutions to problems or challenges. The more widely that a project appears to have ownership, the easier it will be for it to be widely accepted. Bringing cross functional teams together also helps to spread knowledge across an organization. Recognizing and rewarding collective behavior across cross functional teams can also help to increase teams' cohesion. Another way to improve collaboration is by using tooling. Tools like Teams, Slack, Dropbox, and Skype are examples of these communication tools. Other common tools that include collaboration offering include Google Hangouts, WebEx, GoToMeeting, FlowDoc, Asana, ProofHub, Redbooth, Trello, Darpulse, and many others. Let's discuss how can you select tools and processes for agile practices. While developing using agile methods doesn't require specific tooling, the use of tools can often enhance the outcomes achieved. It's important to realize, though, that the most important tool for agile development is the process itself. You should become familiar with the processes that you need to follow before you try to work out how to implement tools. Several categories of tools are commonly used. Let's look into physical tools. Note that not all tools need to be digital tools. Many teams make extensive use of whiteboards for collaborating on ideas, index cards for recording stories, and sticky notes for moving tasks around. Even when digital tools are available, it might be more convenient to use these physical tools during stand up or other meetings. Second is collaboration tools. I have discussed these collaboration tools like Teams, Slack, Dropbox, and other common tools in the previous slide. And the last one is project management tools. These tools usually include project planning and execution monitoring abilities, automation for stand-up meetings, management and tracking of releases, and a way to record and work with the outcomes. Many include Kanban boards and detailed sprint planning options. It might seem odd to add screen recording tools into the list, but they are really helpful when working with remote team members for recording bugs in action and for building walkthroughs and tutorials that demonstrate actual or potential features. There is a screen recorder built into Windows, but other common tools include Snaggled, Camtasia, OBS, and Loom. And that concludes this lesson. In this episode, we're going to learn about what is Azure DevOps and what can Azure DevOps do for you, and a high-level view on what is Azure boards, pipeline, repos, artifacts, and test plans. So what is Azure DevOps and what can Azure DevOps do for you? Azure DevOps is a software and a service platform from Microsoft that provides an end-to-end DevOps toolchain for developing and deploying software. It also integrates with most leading tools on the market, and it is a great option for orchestrating a DevOps toolchain. Azure DevOps comprises a range of services covering the full development lifecycle. This include Azure Boards for agile planning, work item tracking, visualization, and reporting tool. You can use Azure Pipeline, a language platform, and a cloud-agnostic CI/CD platform which supports for containers or Kubernetes. You could use Azure Repos, which provides cloud-hosted private Git repos, and Azure Artifacts, which provides integrated package management with support for Maven, NPM, Python, and NuGet packages feeds from public or private sources, and Azure Test Plans, which provides an integrated planned and exploratory testing solution. And Azure DevOps can also be used to orchestrate third-party tools as well. First, let's talk about what is Azure Boards. Azure Boards is a service for managing the work for your software projects. Teams need tools that flex and grow. Azure Boards does just that, bringing you a rich set of capabilities, including native support for Scrum and Kanban, and customizable dashboards and integrated reporting. All work in Azure Boards is tracked through an artifact called a work item. Work items are where you and your team describe the details of what's needed. Each work item uses a state model to track and communicate progress. And Azure Boards provide a variety of choices for planning and managing work. This include boards, backlogs, sprints, dashboards, queries, etc. Now let's understand what is Azure Pipelines. Azure Pipelines supports automatically build and test of code projects to make them available to others. It works just about any language or project type. Azure Pipelines combines continuous integration and continuous delivery to constantly and consistently test and build your code and ship it to any target. The starting point for configuring CI/CD for your application is to have your source code in a version control system. To use Azure Pipelines, you need an organization in Azure DevOps and to have your source code stored in a version control system. And implementing CI/CD pipelines help you ensure consistent and quality code that are readily available to users. And the Azure Pipelines provide a quick, easy, and safe way to automate building your projects and making them available to users. And Azure Pipelines support work with any language or platform, deploys to different types of target at the same time, integrates with Azure deployments, built on Windows, Linux, and Mac machines, and integrates with GitHub and works with open source projects as well. Now let's understand what is Azure Repos. Azure Repos is a set of version control tools that you can use to manage your code. Whether your software project is large or small, using version control as soon as possible is a good idea. Version control systems are software that helps you track changes you make in your code over time. As you edit your code, you tell the version control system to take a snapshot of your files, and the version control system saves the snapshot permanently so you can recall it later if you need it. And you can use the version control to save your work and coordinate code changes across your team. Even if you are just a single developer, version control helps you stay organized as you fix bugs and develop new features. And version control keeps a history of your development so that you can review and even roll back to any version of your code with ease. And Azure repos provide two types of version control: Git, which is a distributed version control, and Team Foundation Version Control or TFVC, which is a centralized version control. Now let's look into Azure Artifacts. Azure Artifacts introduces the concept of multiple feeds that you can use to organize and control access to your packages. If you're familiar with using packages from NuGet.org or npm.js, you can think of those places each as a single feed. To start using Azure Artifacts, you need to have a project collection administrator or organizational owner permissions. And your network connection must be set up to allow certain IP addresses and domain URLs. If you plan to use more than the free usage tier of 2 GB, you must set up billing for your organization. Now let's look into what are Azure test plans. Azure test plans or Test Hub in Azure DevOps Server provides three main types of test management artifacts: test plans, test suites, and test cases. These elements are stored in your work repository as special type of work items, and you can export and share them with your team and benefit from close integration for all of your DevOps tasks. After you create your test plan, you assign test configuration and assign testers to cover required test metrics. These testers run the test and gauge the quality of the product. And testers continue testing until the product meets exit criteria. For the next development cycle and release, you can create a new test plan and reuse the same test cases. You repeat this development test release cycle by importing the same test case into each new test plan. To manage test artifacts, you must have the correct permission and access level. So that concludes this lesson. In this episode, we're going to learn about migrating to Azure DevOps. Within that, we will learn about what is GitHub and what if you are not a Microsoft .NET organization, what can you do about it? So what is GitHub and what is it used for? To understand GitHub, you must first have an understanding of Git. Git is an open source version control system. So what makes GitHub so special? Git is a command line tool, but it centers around which all things involving Git revolves in the hub, where developers store their projects and network with like-minded people. GitHub is where you can record or rewind any changes to your code to keep you and your team in sync. So what if you are not a Microsoft or .NET organization? Azure DevOps is not focused at organizations that are end-to-end Microsoft or Windows. Azure DevOps provide a platform that is flexible so that you don't have to go all in on Azure DevOps. It is possible to adopt each of these services independently and integrate them with your existing toolchain. And most popular tools are supported. And Azure DevOps is cross-platform as well. It is designed to work with any platform such as Linux, Mac operating system, or Windows, or languages including Node.js, Python, Java, PHP, Ruby, C, C++, .NET, Android, and iOS apps. Azure DevOps is not just aimed at organizations building and shipping on Microsoft technology stack. And Azure DevOps is cloud agnostic. Continuous delivery is supported to AWS and GCP as well as to Azure. Let's look into how you can design an authorization and access strategy. Azure DevOps Services uses enterprise-grade authentication. You can use either a Microsoft account, GitHub account, or Azure Active Directory to protect and secure your data. Many client applications such as Visual Studio or Azure DevOps natively supports this indication by another Microsoft account or Azure AD. When you need a non-Microsoft tool like Git, NuGet, or Xcode to integrate directly with Azure DevOps services, and tools don't directly support Microsoft account or Azure AD for authentication, you can still use them by setting up personal access tokens. These tokens can be set up using Git credential managers, or you can create them manually. Personal access tokens are also useful when you need to establish access in command line tools or in tools and tasks in build pipelines, and when calling REST-based APIs because you don't have a UI popping out to perform the authentication. When access is no longer required, you can then just revoke the personal access token. Azure DevOps is pre-configured by default directory groups, and the default permissions are assigned to the default security groups. But you can also configure access to the organizational level, the collection level, and at the project or object level. In the organizational setting in Azure DevOps, you can configure app access policies. Based on your security policies, you might allow alternate authentication methods and allow third-party application to access via OAuth, or even allow anonymous access to some projects. For even tighter control, you can set conditional access to Azure DevOps. This offers simple ways to help secure resources when using Azure Active Directory for authentication. Conditional access policies such as multi-factor authentication can help you minimize the risk of compromised credentials. As part of a conditional access policy, you might require security group membership, a location or network identity, a specific operating system, a managed device, or other criteria. Let's look into migrating or integrating existing work management tools. Azure DevOps can be integrated with a variety of existing work management tools. As an example, in the Visual Studio Marketplace, Microsoft offers Twilio integration tooling. Migrating from other work management tools to Azure DevOps takes considerable planning. Most work management tools are highly configurable by the end user. This means that there might not be a tool available that will perform the migration without further configuration. Jira is commonly used work management tool. In the Visual Studio Marketplace, Solidify offers a tool for Jira to Azure DevOps migration. It does the migration in two phases. Jira issues are exported to files and then files are imported to Azure DevOps. If you decide to try to write the migration code yourself, you can do it as well. There are lots of blogs which provide a sample code that might help you get started in that. Third-party organizations do offer commercial tooling to assist with migrating other work management tools like AHA, Bazilla, ClearQuest, and others to Azure DevOps. Let's look into migrating or integrating existing test management tools. Azure test plans are used to track manual testing for sprints and milestones. This allows you to track when the testing is complete. And Azure DevOps also has a test and feedback extension available in Visual Studio Marketplace. The extension is used to help teams perform exploratory testing and provide feedback. All team members, including developers, product owners, managers, UX and UI engineers, marketing teams, early adopters, and other stakeholders can use the extension to submit bugs or provide feedbacks. Apache JMeter is open source software written in Java and designed to load test functional behavior and measure performance. And Pester is a tool that can be used to automate the testing of PowerShell code. And SOAP UI is another testing framework for SOAP and REST testing. If you are using Microsoft Test Manager, you should plan to migrate to using Azure Test Plan instead. We just finished Module 1 on AZ-400, which is Microsoft Certified Azure DevOps Engineer Expert. In this video, we're going to do a quick knowledge check on Module 1. So let's look into the first question. Which of the following would a system that manages inventory in a warehouse be considered? The correct answer is system of record. Systems that are providing the truth about data elements are often called systems of record. Let's look at question number 2. An agile tool that is used to manage and visualize work by showing tasks moving from left to right across columns representing stages. What is this tool commonly called? The correct answer is Kanban board. A Kanban board lets you visualize the flow of work and constrain the amount of work in progress. Your Kanban board turns your backlog into an interactive signboard, providing a visual flow of work. Let's look at question number 3. In which of the following would you find a large amount of technical debt? The right answer is brownfield project. A brownfield project comes with the baggage of existing code bases, existing teams, and often a great amount of technical debt. They can still be ideal project for DevOps transformations. Question number 4. As a project metric, what is lead time measuring? The right answer is lead time measuring is how long it takes from starting on a work item until it is deployed. Question number 5. What is a cross-functional team? The correct answer is a team that brings people with different functional expertise and often from different departments together to work towards a common goal. That concludes this knowledge check episode. In this episode, we're going to learn about what is source control and what are the foundational practices of DevOps. So, what is source control? DevOps has been an emerging trend in software development world for the past several years. While the term may be relatively new, it is really convergence of a number of practices that have been evolving for decades. DevOps is a revolutionary way to release software quickly and efficiently while maintaining a high level of security. While it has proven to be the wave of the future, many still have yet to hop on board the DevOps train. Let's be honest, version control isn't exactly a topic you would bring up at the dinner party to spice up the conversation. Managing file versions and meticulously reviewing code for errors can be a dull subject. In fact, it rarely makes the headlines. Even in the software development news, where there are far more exciting trends to cover than AI or data science, etc. But much like no one really talks about putting a clean socks in the morning, setting an alarm at night, or looking both ways before crossing the street, version control is an essential everyday practice. Versioning is a common part of developers' routine and if leveraged correctly can save organization enormous cost and resources. Though version control is today a common sense aspect of programming, it is important from time to time to look at why do what we do and how versioning impacts the entire value stream at an organization. Now let's look at what is source control. Source control or version control is the practice of tracking and managing changes to code. Source control management or SCM systems provide a running history of code development and help to resolve conflicts when merging contributions from multiple sources. For most software teams, the source code is a repository of the invaluable knowledge and understanding about the problem domain that the developers have collected and refined through careful effort. Version control protects source code from both catastrophe and casual degradation of human error and unintended consequences. Without version control, you are tempted to keep multiple copies of your code on your computer. This is dangerous. It's easy to change or delete a file in the wrong copy of code, potentially losing the work. Version control systems solve this problem by managing all versions of your code by presenting you with a single version at a time. Before we dive into details of source control, Let me clarify some of the common goals for software teams. The first one is reusability. Why do the same thing twice? Reuse of code is a common practice and makes building on existing assets simpler. Second value is traceability. Audits are not just for fun. In many industries, this is a legal matter. All activity must be traced and managers must be able to produce reports when needed. Traceability also makes debugging and identifying root cause earlier. Additionally, this will help with feature reuse as developers can link requirements to implementation. Next value is manageability. Can team leaders define and enforce workflows, review rules, create quality gates, and enforce QA throughout the lifecycle? Another value is efficiency. Are we using the right resources for the job? And are we minimizing time and efforts? This one is pretty self explanatory. Another value is collaboration. When teams work together, quality tends to improve. We catch one another's mistakes and can build on each other's strengths. Last value is learning. Organizations benefit when they invest employees learning and growing. This is not only important for onboarding new team members, but for the lifelong learning of seasoned members and the opportunity for workers to contribute not just to the bottom line, but to the industry as the whole. So, tools and processes are not enough to accomplish the values, hence, the adoption of agile continuous integration and DevOps. Believe it or not, all of these rely on solid version control practice. And version control is about keeping track of every change to software assets, tracking and managing the who, what, and when. Let's look at the foundational practices of DevOps. In the effort to eliminate the enigma that comes with new business practice, the 2019 State of DevOps report highlights version control in almost all stages of DevOps evolution. Also, it's helpful for non-developers at an organization to understand the fundamental of a principle that is so deeply rooted in the daily life of a software engineer, especially if those individuals are making decisions about which version control tools and platforms to use. And version control is very important for all software development projects and is particularly vital at large business and enterprise. Enterprises have many stakeholders, distributed teams, strict processes and workflows, siloed organization and hierarchical organizations, etc. All of those characteristics represent coordination and integration challenges when it comes to merging and deploying code. Even more so in companies within high regulated industries such as in banking and healthcare, with many rules and regulations, need a practical way to ensure that all standards are being met appropriately and risk is mitigated. Now let's understand the benefits of source control. Code doesn't exist unless it's committed into source control. And source control is the fundamental enabler of continuous delivery. Whether you are writing code professionally or personally, you should always version your code using a source control management system. So let me tell you some of the advantages of using source control. The first one is it will help you create workflows. Version control workflow prevent the chaos of everyone using their own development process with different and incompatible tools. And version control systems provide process enforcement and permissions so everyone stays on the same page. Second benefit is work with versions. Every version has a description in the form of a comment. These descriptions help you follow changes in your code by version instead of by individual file changes. And code stored in version can be viewed and restored from a version control at any time as needed. This makes it easy to base new work off any version of code. Another advantage is collaboration. Version control synchronizes versions and makes sure that your changes doesn't conflict with other changes from your team. Your team relies on version control to help resolve and prevent conflicts even when people make changes at the same time. Another advantage is it maintains history of changes. Version control keeps a history of changes as your team saves new version of your code. This history can be reviewed to find out who, why, and when changes were made. And history gives you the confidence to experiment since you can roll out to a previous good version at any time. And history lets you base work from any version of code, such as fix a bug in a previous release. And another advantage is automate tasks. Version control automation features save your team time and generate consistent results. Automate testing, code analysis, and deployment when new versions are saved to version control. Now let's look at some of the best practices for source control. The first one is you can make small changes. In other words, you can commit early and commit often. Of course, be careful not to commit any unfinished work that could break the build. Second best practice is don't commit personal files. These could include application settings or SSH keys. Often, these are committed accidentally but cause problems later down the line when other team members are working on the same code. Third best practice is update often and right before pushing to avoid merge conflicts. Another best practice is verify your code change before pushing it to a repository. Ensures it complies and tests are passing. Pay close attention to commit messages as these will tell you why a change was made. So consider commit messages as a mini form of documentation for the change. The next one is you can link code changes to work items. This will concretely link what was created to why it was created or changed by providing traceability across requirements and code changes. And the last one is no matter your background or preferences, be a team player and follow agreed conventions and workflows. So, consistency is very important and helps ensure quality, making it easier for team members to pick up where you left off, to review your code, to debug, etc. Using version control of some kind is necessary for any organization, and following the guidelines can help developers avoid needless time spent fixing errors and mistakes. These practices also help organizations reap greater benefits from having a good version control system. That concludes this lesson. In this episode, we're going to learn about different types of source control systems, which include centralized version control and distributed version control. Let us start with understanding what is centralized version control. Centralized version control systems are based on the idea that there is a single central copy of your project somewhere, probably on a server, and programmers will check in or commit their changes to this central copy. Committing a change simply means recording the change in the central system. Other programmers can then see this change. They can also pull down the change, and the version control tool will automatically update the contents of any files that were changed. Most modern version control systems deal with change sets, which simply are a group of changes, possibly to many files, that should be treated as a cohesive whole. For example, a change to C header file and the corresponding .c file should always be kept together. Programmers no longer have to keep many copies of the files on their hard drives manually, because the version control tool can talk to central copy and retrieve any version they need on the fly. Some of the most common centralized version control systems you may have heard or used are TFVC or CVS or Subversion or SVN or Perforce. Let's look at a typical centralized version control workflow. When you're working with a centralized version control system, your workflow for adding a new feature or fixing a bug in your project will usually look something like this. Get the latest changes other people have made from their central server, make your changes and make sure they work properly, and check your changes to the central server or other programmers can see them. Now let's look at distributed version control. In the past 5 years or so, a new breed of tools has appeared, so-called distributed version control system, or DVCS for short. The three most popular of these are Mercurial, Git, and Bazaar. These systems do not necessarily rely on a central server to store all the versions of a project's files. Instead, every developer clones a copy of a repository and has the full history of the project on their own hard drive. This copy or clone has all the metadata of the original. This method may sound wasteful, but in practice, it's not a problem. Most programming projects consist mostly of plain text files and maybe few images. And this space is so cheap that storing many copies of a file doesn't create a noticeable dent in a hard drive's free space. Modern system also compresses the files to use even less space. The act of getting new changes from a repository is usually called pulling, and the act of moving your own changes to a repository is called pushing. In both cases, you move change sheets, not single file differences. One common misconception about distributed version control system is that there cannot be a central project repository. This is simply not true. There is nothing stopping you from saying this copy of the project is the authoritative one. This means that instead of a central repository being required by the tools you use, it is now optional and purely a social issue. Now let's look at the advantages over centralized version control. The act of cloning an entire repository gives distributed version control tools several advantages over centralized systems. So let me tell you all these advantages over central version control one by one. The first one is performing actions other than pushing and pulling change sets is extremely fast because the tool only needs to access the hard drive, not a remote server. Second one is committing new change sets can be done locally without anyone else seeing them. Once you have a group of change sets ready, you can push all of them at once. Another one is everything but pushing and pulling can be done without an internet connection. So you can work on a plane and you won't be forced to commit several bug fixes as a big change set. Another advantage is since each programmer has a full copy of the project repository, you can share changes with one or two other people at a time if they want to get some feedback before showing the changes to everyone. So is there any disadvantages compared to centralized version control? There are almost no disadvantages to using a distributed version control system over a centralized one. Distributed systems do not prevent you from having a single central repository. They just provide more option on top of that. So let's look at a couple of inherent disadvantages of using a distributed systems. If your project contains many large binary files that cannot be easily compressed, the space needed to store all versions of the files can accumulate quickly. Another disadvantage could be if your project has a very long history, downloading the entire history can take an impractical amount of time and disk space. Now let us look into what is Git and TFVC. First, let's look at Git. Git is a distributed version control system. Each developer has a copy of the source repository on their dev machine, and developers can commit each set of changes on their dev machine and perform version control operations such as history and compare without a network connection. Branches are lightweight. When you need to switch context, you can create a private local branch, and you can quickly switch from one branch to another to pivot among different versions of a code base. Later, you can merge, publish, or dispose of the branch. So what is TFVC? TFVC is Team Foundation Version Control. And Team Foundation Version Control is a centralized version control system. Typically, team members have only one version of each file on their dev machines. Historical data is maintained only on the server, and branches are path-based and created on the server. And TFVC has two workflow models: server workspaces and local workspaces. So, so what is server workspaces? Before making changes, team members publicly check out files. Most operations require developers to be connected to the server. This system facilitates locking workflows. Other systems that work this way include Visual Source Safe, Perforce, and CVS. With server workspaces, you can scale up to very large code bases with millions of files per branch and large binary files. So, what is local workspaces? Each team member takes a copy of the latest version of the code base with them and work offline as needed. Developers check in their changes and resolve conflicts as necessary. Another system that works this way is Subversion. So that concludes this episode. In this episode, we're going to learn about why Git, and then we will learn what is community and what are distributed development, etc. Switching from a centralized version control system to Git changes the way your development team creates software. And if you are a company that relies on its software for mission critical applications, altering your development workflow impacts your entire business. Developers can gain benefits by moving into Git. First, let's understand what is community. In many circles, Git has come to be the expected version control systems for new projects. If your team is using Git, odds are you won't have to train new hires on your workflow because they will already be familiar with the distributed development. In addition, Git is very popular among open source projects. This means that it's easy to leverage third-party libraries and encourage others to fork your own open source code. Let's talk about distributed development. In TFVC, each developer gets a working copy that points back to a single central repository, Git. However, Git is a distributed version control system. Instead of a working copy, each developer gets their own local repository complete with a full history of commits. Having a full local history makes Git fast since it means that you don't need a network connection to create commits, inspect previous version of a file, or perform differences between commits. Distributed development also makes it easier to scale your engineering team. If someone breaks the production branch in SVN, other developers can't check in their changes until it's fixed. With Git, this kind of blocking doesn't exist. Everybody can continue going about their business in their own local repositories. And similar to feature branches, distributed development creates a more reliable environment. Even if a developer obligates their own repository, they can simply clone someone else's and start afresh. So, what is trunk-based development? One of the biggest advantages of Git is its branching capabilities. Unlike centralized version control systems, Git branches are cheap and easy to merge. Trunk-based development provides an isolated environment for every change to your code base. When a developer wants to start working on something, no matter how big or small, they create a new branch. This ensures that the master branch always contains production quality code. Using trunk-based development is not only more reliable than directly editing production code, but it also provides organizational benefits. They let you represent development work at the same granularity as your agile backlog. For example, you might implement a policy where each work item is addressed in its own feature branch. Now let's understand what is pull request. Many source code management tools such as Azure Repos enhance core Git functionality with pull request. A pull request is a way to ask another developer to merge one of your branches into their repository. This not only makes it easier for project leads to keep track of changes, but also let developers initiate discussions around their work before integrating it with the rest of the code base. Since they are essentially a common thread attached to a feature branch, pull requests are extremely versatile. When a developer gets stuck with a hard problem, they can open a pull request to ask for help from the rest of the team. Alternately, junior developers can be confident that they aren't destroying the entire project by treating pull request as a formal code review. Let's discuss the faster release cycle. The ultimate result of feature branches, distributed development, pull requests, and a stable community is a faster release cycle. These capabilities facilitate an agile workflow where developers are encouraged to share smaller changes more frequently. In turn, changes can get pushed down the deployment pipeline faster than the monolithic releases common with centralized version control systems. As you might expect, Git works very well with continuous integration and continuous delivery environments. And Git hooks allow you to run scripts with certain events occur inside of a repository, which lets you automate deployment to your heart's content. You can even build or deploy code from specific branches to different servers. For example, you might want to configure Git to deploy the most recent commit from the developed branches to a test server whenever everyone merges a pull request into it. Combining this kind of build automation with peer review means you have the highest possible confidence in your code as it moves from development to staging to production. There are 5 common objections I often hear to migrating to Git. Let's look at these 5 one by one. They are: I can overwrite history, I have large files, I have very large repo, I don't want to use GitHub, and there is a steep learning curve. Now let's talk about overwriting history. Git technically does allow you to overwrite history, but like any useful feature, if used incorrectly, can cause conflicts. If your teams are careful, they should never have to overwrite history. And if you're synchronizing to Azure repos, you can also add a security rule that prevents developers from overwriting history by using the explicit force push permissions. Every source control system works best when the developers using it understand how it works and which conventions work. While you can't overwrite history with TFVC, you can still overwrite code and do other painful things. Let's discuss about the large files. Git works best with repos that are small and that does not contain large files or binaries. Every time you clone the repo, they get the entire repo with all its history from the first commit. This is great for most situations, but can be frustrating if you have large files. Binary files are even worse since Git just can't optimize how they are stored. That's why Git LFS was created. This lets you separate large files out of your repos and still have all the benefits of versioning and comparing. Also, if you are used to storing compiled binaries in your source repos, stop. Use Azure Artifacts or some other package management tool to store binaries you have source code for. However, teams that have large files like 3D models or other assets, you can use Git LFS to keep your code repos slim and trim. Let's discuss about large repos. But fortunately, the engineers at Microsoft have been on a multi-year journey to convert all of Microsoft source code to Git. Windows team has a repo that's over 300 GB in size, and they use Git for source control. How? They invented Virtual File System or VFS for Git. VFS for Git is a client plugin that lets Git think that it has the entire repo, but only fetches files for the upstream repo while the file is touched. This means that you can clone your giant repo in few seconds. Only when you touch files does Git fetch them down locally. In this way, the Windows team is able to use Git even for their giant repo. Let's discuss Git or GitHub. There is a lot of confusion about Git versus GitHub. Git is a distributed source control system created by Linus Torvalds in 2005 for the Linux kernel. If you create a repo, you have a fully functioning Git repo on your local machine. However, to share the code, you need to pick a central place that developers can use to synchronize their repos. So if I want your changes, you would push your changes to the central repo and I would pull them from there. We are still both working totally disconnected, but we are able to share our code via that push-pull model. GitHub is a cloud service for hosting these sort of centralized repos. This is made famous mostly because it's free for open source projects. So you can host unlimited public repos. You don't have to use GitHub to use Git. Though it's pretty much the de facto platform for open source code, they do offer private repos too. You can also create Git repos in Team Foundation Server and TFS 2015 to TFS 2019. That is renamed to Azure DevOps Server recently. Now let's discuss about the learning curve. There is a learning curve. If you have never used source control before, you are probably better off when learning Git. I have found that users of centralized source control, which is TFVC or Subversion, battle initially to make the mental shift, especially around the branches and synchronizing. Once developers grok how Git branches work and get over the fact that they have to commit and then push, they have all the basics they need to be successful in Git. That concludes this lesson. In this episode, you're going to learn about what is Azure Repos and what is GitHub. So what is Azure Repos? Azure Repos is a set of version control tools that you can use to manage your code. Whether your software project is large or small, using version control as soon as possible is a good idea. Azure Repos provide two types of version control, Git and TFVC. Git is a distributed version control and Team Foundation version control is a centralized version control. So let us look at what do you get with Azure Repos. First, you get a free private Git repositories, pull request and code search, and get unlimited private Git repository hosting and support for TFVC that scales from a hobby project to the world's largest repository. Then you will get support for any Git client. You can use that to securely connect with and push code into your Git repos from any IDE editor or Git client. Then we have webhooks and API integration. This add validations and extensions from the marketplace or build your own webhooks and REST APIs. We have semantic code search, which you can use to quickly find what you are looking for with code-aware search that understand classes and variables. With Azure Repos, you can collaborate to build better code. With Azure Repos, you can perform effective Git code reviews with threaded discussion and continuous integration for each change, and use fork to promote collaboration with inner source workflows. Then we have automate with built-in CI/CD. This helps you set up continuous integration and continuous delivery CI/CD to automatically trigger builds, tests, and deployments with every completed pull request using Azure pipelines or your tools. Then we have protect your code quality with branch policies. Keep code quality high by requiring code reviewer sign-off, successful builds, and passing tests before pull requests can be merged. And you can customize your branch policies to maintain your team's high standards. And finally, you can use with your favorite tools as well. So you can use Git and TFVC repositories on Azure Repos with your favorite editor and IDE. Now let's understand what is GitHub. GitHub is the largest open source community in the world, and GitHub is owned by Microsoft. And GitHub is a developer platform inspired by the way you work. From open source to business, you can host and review code and manage projects and build software alongside 40 million developers. And GitHub is a Git repository hosting service, but it adds many of its own features. While Git is a command line tool, GitHub provides a web based graphical interface. It also provides access control and several collaboration features such as wikis and basic task management tools for every project. So, what are the main benefits of using GitHub? To be honest, nearly every open source project uses GitHub to manage their project. Using GitHub is free if your project is open source and includes a wiki and issue tracker that makes it easy to include more in-depth documentation and get feedback about your project. Let us look into some of the features offered by GitHub. First, you can use GitHub to automate from code to cloud. With this, you can cycle your production code faster and simplify your workflow with GitHub packages and built-in CI/CD using GitHub Actions. You can either use automate your workflow or you can package at home with their own code as well. Second feature is securing software together. GitHub play a role in securing code used by developers, maintainers, researchers, and security teams. On GitHub, development teams anywhere can work together to secure the world's software supply chain from fork to finish. You can get alerts about vulnerabilities in your code. You can automatically update vulnerabilities, stay on top of CVEs, find vulnerabilities that other tools miss, and you can eliminate variants and keep your tokens safe. Another feature is seamless code review. Code review is surest path to better code, and it's fundamental to how GitHub works. Built-in review tools make code review an essential part of your team's process. You can propose changes, request reviews, see the difference, comment in context, give clear feedback, and protect branches. Another feature is all your code and documentation is in one place. There are hundreds of millions of private, public, and open source repositories hosted on GitHub. Every repository is equipped with tools to help you host, version, and release code and documentation. With this, you can code where you collaborate and documentation alongside your code as well. Another feature is managing your idea. So you can coordinate early, stay aligned, and get more done with GitHub's project management tools. With this, you can see the project's big picture and track and assign tasks. Another feature is managing the teams. This is the human side of software. Building software is as much about managing teams and communities as it is about code. Whether you are on a team of 2 or 2,000, GitHub's got the support your people need. With GitHub, you can manage and grow teams, keep conversations on topic, and set community guidelines. That concludes this lesson. In this episode, we're going to learn about how can you migrate from Teams Foundation Version Control, TFVC, to Git in Azure repos. Alright, so let's start with understanding how can you migrate the tip. Most teams wish they could recognize their source control structure. Typically, the structure the team is using today was set up by a well-meaning developer a decade ago, but it's not really optimal. Migrating to Git could be a good opportunity to restructure your repo. In this case, it probably doesn't make sense to migrate history anyway, since you're going to restructure the code. The process is simple. Create an empty Git repo, then get latest from TFS and copy the code into the empty Git repos. Then you just commit and push, you are there. Of course, if you have shared code, you need to create build of the shared code to publish to a package feed and then consume those packages in downstream applications. But the Git part is really simple. And if you are on TFVC and you are in Azure DevOps, then you have the option of a simple single branch import You can click on Import Repository from the Azure repos. Then enter the path to the branch you are migrating and select if you want history or not. You can keep up to 180 days and add in a name for the repo and the import will be triggered. Import repository also allows you to import a Git repository. This is essentially useful if you are looking to move your Git repository from GitHub or any other public or private hosting spaces into Azure repos. To make it easier for you to switch from TFSE to Git, Azure DevOps Server now provides an out-of-the-box migration workflow called Import Repository. The Import Repository option can be reached from the Code Hub. This allows you to migrate a TFVC repository into Git with history. This is an example which shows how you can do the import. Now let's look into how you can authenticate to Git in Azure repos. Git Credential Manager simplify authentication with your Azure DevOps Service and TFS Git repos. Credential managers let you use the same credential that you use for the Azure DevOps services and support multi-factor authentication through Microsoft account or Azure Active Directory. In addition to supporting MFA with Azure DevOps services, the Credential Manager also provides support two-factor authentication with GitHub repositories. So for Windows, you can download and install the latest Git for Windows installer, which includes the Git Credential Manager for Windows. Make sure to leave the Git Credential Manager installation option enabled when prompted. On Mac OS and Linux, there are several install options that use native package managers to install the Credential Manager. We just completed Module 2. In this episode, we're going to look into Module 2 review questions. So without wasting any more time, let's get into it. Let's look at question number 1. What are some of the benefits of source control? And select all. So except accountability, all of the other options mentioned over here are the benefits of source control. Reusability, collaboration, manageability, efficiency, traceability, and automate tasks. Source control is the practice of tracking and managing changes to code. Benefits include reusability, traceability, manageability, efficiency, collaboration, learning, create workflows, work with versions, collaboration, maintains history of changes, and automate tasks. Question number 2. What are the benefits of using distributed version control? Select all. The right answers are complete offline support and cross-platform support. Question number 3. What are the benefits of using centralized version control? The right answers are easily scales for very large code bases and granular permission control. Question number 4. What is source control? Source control is the practice of tracking and managing changes to code. Alright, so that concludes Module 2. In this episode, we're going to learn about how to structure your Git repos. Within that, we are going to learn about mono versus multi-repos and Git branching workflows as well. Alright, so first let's understand mono versus multi-repos. A repository is simply a place where the history of your work is stored. It often lives in a .git subdirectory of your working copy. So what's the best way to organize your code repository? Software development teams start off with the best intention to keep clear separation of concerns in both the software being development and their code repositories. However, over time, it is not uncommon for the code repositories to be blotted with unrelated code and artifacts. There are two philosophies on how to organize your repos: monorepo or multi-repo. Monorepos are a source control pattern where all the source code is kept in a single repository. This makes it super simple to give all of your employees access to everything in one shot. Just clone it down and done. Multi-repos, on the other hand, refers to organizing your projects each into their own separate repositories. The fundamental difference between the monorepo and multi-repo philosophies boils down to the differences about what will allow teams working together on a system to go fastest. The multi-repo view in the extreme form is that if you let every sub-team live in its own repo, they have the flexibility to work in their area however they want, using whatever libraries, tools, development workflow, etc. And this will maximize their productivity. The cost, obviously, is that anything not developed within a given repo has to be consumed as if it was a third party library or service. If you find a bug in a library you use, you have to fix in the appropriate repo and get a new artifacts published and then go back to your own repo to make the changes to your code. In the other repo, you have to deal with not only a different code base, but potentially with the different libraries and tools, or even a different workflow. Or maybe you just have to ask someone who owns that system to make the change for you and wait for them to get around it. Let's look into Git branching workflows. When evaluating a workflow for your team, it's most important that you consider your team's culture. You want the workflow to enhance the effectiveness of your team and not to be a burden that limits productivity. Some things to consider when evaluating Git workflow are: does this workflow scale with the team size? Or is it easy to undo mistakes and errors with this workflow? Does this workflow impose any new unnecessary cognitive overhead to the team? Most popular Git workflows will have some sort of centralized repo that individual developers will push and pull from. I will take you through some of the most popular Git workflows and then we will go into more detail in the next section. These extended workflows offer more specified patterns in regards to managing branches for feature development, hot fixes, and eventual release. Let's look into what is trunk-based development. Trunk-based development is a logical extension of centralized workflow. The core idea behind the feature branch workflow is that all feature development should take place in a dedicated branch instead of the master branch. This encapsulation makes it easy for multiple developers to work on a particular feature without disturbing the main code base. It also means the master branch should never contain broken code, which is a huge advantage for continuous integration environments. The Git flow workflow was first published in the highly regarded 2010 blog post by Vincent Dierson. The Git flow workflow defines a strict branching model designed around the project release. This workflow doesn't add any new concepts or commands beyond what's required for the feature branch workflow. Instead, it assigns very specific roles to different branches and defines how and when they should interact. The next one is forking workflow. The forking workflow is fundamentally different than the other workflows discussed in this tutorial. Instead of using a single server-side repository to act as a central code base, it gives every developer a server-side repository. This means that each contributor has not one but two Git repositories, a private local one and a public server-side one. The core idea behind the feature branch workflow is that all feature development should take place in a dedicated branch instead of the master branch. Encapsulating feature development also makes it possible to leverage pull requests, which are a way to initiate discussions around a branch. They give other developers the opportunity to sign off on a feature before it gets integrated into the official project. Or if you get stuck in the middle of a feature, you can open a pull request asking for suggestions from your colleagues. The point is, pull requests make it incredibly easy for your team to comment on each other's work. In addition, feature branches can be pushed to the central repository. This makes it possible to share a feature with other developers without touching any official code. Since master is the only special branch storing several feature branches on the central repository, which doesn't pose any problems. Of course, this is also a convenient way to back up everybody's local commits. So let us have a look into how this feature branch workflow is going to look. First, let's understand how it is going to work. The trunk-based deployment workflow assumes a central repository, and the master represents the official project history. Instead of committing directly on their local master branch, developers create a new branch every time they start work on a new feature. And feature branches should have descriptive names. The idea is to give a clear, highly focused purpose to each branch. And Git makes no technical distinction between the master branch and the feature branches. So developers can edit, stage, and commit changes to a feature branch. So let's look into how you can create a branch. When you're working on a project, you're going to have a bunch of different features or ideas in progress at any given time, some of which are all ready to go and others which are not. Branching exists to help you manage this workflow. When you create a branch in your project, you are creating an environment where you can try out new ideas. Changes you make on a branch doesn't affect the master branch, so you are free to experiment and commit changes and save in the knowledge that your branch won't be merged until it's ready to be reviewed by someone you're collaborating with. Branching is a core concept in Git, and the entire branch flow is based upon it. There is only one rule: anything in the master branch is always deployable. Because of this, it's extremely important that your new branch is created off of master when working on a feature or a fix. Your branch name should be descriptive. For example, refactor authentication, user content cache key, make retina avatars, etc., so that others can see what is being worked on. Now let us look into how can you add commits. Once your branch has been created, it's time to start making changes. Whenever you add, edit, or delete a file, you are making a commit and adding them to your branch. This process of adding commits keeps track of your progress as you work on a feature branch. Commits also create a transparent history of your work that others can follow to understand what you have done and why. Each commit has an associated commit message, which is a description explaining why a particular change was made. Furthermore, each commit is considered a separate unit of change. This lets you roll back changes if a bug is found or if you decide to head in different direction. Commit messages are important, especially since Git tracks your changes and then displays them as commits once they are published to the server. By writing clear commit messages, you can make it easier for other people to follow along and provide feedback. Now let's look into how you can open a pull request. Pull requests initiate discussion about your commits because they are tightly integrated with the underlying Git repository. Anyone can see exactly what changes would be merged if they accept your request. You can open a pull request at any point during the deployment process. And pull requests are useful for contributing to project and for managing changes to shared repositories. If you're using fork and pull model, pull requests provide a way to notify project maintainers about the changes you like them to consider. If you're using a shared repository model, pull requests help start code review and conversation about proposed changes because they are merged into the master branch. Now let's look into discuss and review your code. Once a pull request has been opened, the person or team reviewing your changes may have questions or comments. You can also continue to push to your branch in light of discussion and feedback about your commits. If someone comments that you forgot to do something or if there is a bug in the code, you can fix it in your branch and push up the change. Git will show your new commits and any additional feedback you may receive in the unified pull request view. And pull request comments are written in Markdown so you can embed images, emojis, or use pre-formatted text blocks and other lightweight formatting. Now let's look into how can you deploy. With Git, you can deploy from a branch for final testing in an environment before merging to master. Once your pull request has been reviewed and the branch passes your test, you can deploy your changes to verify them. And if your branches cause issues, you can roll it back by deploying the existing master. How can you merge? Now that your changes has been verified, it is time to merge your code into the master branch. Once merged, pull requests preserve a record of the historical changes to your code because they are searchable. They let everyone go back in time to understand why and how a decision was made. By incorporating keywords into the text of your pull request, you can associate issues with code. When your pull request is merged, the related issues can also be closed. Alright, so that concludes this lesson. In this episode, we're going to learn about Git flow branch workflow. The purpose of writing code is to ship enhancements to your software. A branching model that introduces too much process overhead does not help to increase the speed with which you can get changes out to customers. It is therefore important to come up with a branching model that gives you enough padding to not ship poor quality changes, but at the same time, not introduce too many processes to slow you down. The internet is full of branching strategies for Git. While there is no right or wrong, a perfect branching strategy is one that works for your team. Git flow is ideally suited for projects that have scheduled release cycle. This workflow doesn't add any new concepts or commands beyond what's required for a feature branch workflow. Instead, it assigns very specific role to different branches and define how and when they should interact. So how can you get started? Git flow is really just an abstract idea of a Git workflow. This means it dictates what kind of branches to set up and how to merge them together. The Git flow toolset is an actual command line tool that has an installation process. The installation process for Git flow is straightforward. Packages for Git flow are available on multiple operating systems as well. On OS X systems, you can execute brew install Git flow, and on Windows systems, you will need to download and install Git flow. After installing Git flow, you can use it on your project by executing Git flow init. Let's look into feature branches. Each new feature should reside in its own branch, which can be pushed to the central repository for backup and collaboration. But instead of branching off of master, feature branches use develop as their parent branch. When a feature is complete, it gets merged back into develop, and features should never interact directly with master. Note that the feature branches combined with the develop branch is, for all intents and purposes, the feature branch workflow. But the Git flow workflow doesn't stop there, and the feature branches are generally created after the latest develop branch. Let's look into release branches. Once develop has acquired enough features for a release, you fork a release branch off of develop. Creating this branch starts the next release cycle, so no new features can be added after this point. Only bug fixes, documentation, and other release-oriented tasks should go in this branch. Once it's ready to ship, the release branch gets merged into master and tagged with a version number. In addition, it should be merged back into develop, which may have progressed since the release was initiated. Using dedicated branch to prepare releases makes it possible for one team to polish the current release, while another team continuously working on features for the next release. It also creates well-defined phases for development. Let's look into what is forking workflow. Forking workflow is fundamentally different than other popular Git workflows. Instead of using a single server-side repository to act as the central code base, it gives every developer their own server-side repository. The main advantage of the forking workflow is that contributions can be integrated without the need for everybody to push to a single central repository. As in the other Git workflows, the forking workflow begins with an official public repository stored on a server. But when a new developer wants to start working on the project, they do not directly clone the official repository. Instead, they fork the official repository to create a copy of it on the server. And when you are ready to publish a local commit, they'll publish the commit to their own public repository, not the official one. So let's look into how is forking different from cloning. It's important to note that fork repositories and forking are not special operations. Fork repositories are created using the standard git clone command, and fork repositories are generally server-side clones and usually managed and hosted by a Git service provider such as Azure Repos. And there is no unique Git command to create forked repositories. A clone operation is essentially a copy of a repository and its history. Now let's look into how can you collaborate with pull requests in Azure Repos. Pull request lets you tell others about changes you have pushed to Git repository. Once a pull request is sent, interested parties can review the set of changes, discuss potential modification, and even push follow-up commits if necessary. Pull requests are commonly used by teams and organizations collaborating using shared repository model, where everyone shares a single repository and topic branches are used to develop features and isolate changes. Many open source projects on GitHub use pull requests to manage changes from contributors, and they are useful in providing a way to notify project maintainers about changes one has made and in initiating code review and general discussion about a set of changes before being merged into the main branch. Pull requests combine the review and merge of your code into a single collaborative process. The code review done in a pull request isn't just to find obvious bugs. That's what your tests are for. A good code review catches less obvious problems and could lead to the costly issues later. And code reviews help protect your team from bad mergers and broken build that sap your team's productivity. That concludes this episode. In this episode, we're going to learn about why you should be caring about Git hooks. Continuous delivery demands a significant level of automation, and you can't be continuously delivering if you don't have a quality code base. This is where Git fares so well, and it gives you the ability to automate most of the checks in your code base even before committing the code into the final repository. Git hooks are a mechanism that allows arbitrary code to be run before or after certain Git lifecycle event occur. For example, one could have a hook into the commit message event to validate that the commit message structure follows the recommended format. The hooks can be any sort of executable code, including shell, PowerShell, Python, or any other scripts. Or they may be a binary executable as well. Anything goes. The only criteria is that hooks must be stored in the .git hooks folder in the repo root, that they must be named to match the corresponding events. So what are the practical use cases for using Git hooks? Since Git hooks simply execute the script on a specific event type, they can be called on. You can do pretty much anything with Git hooks. Some examples of where you can use Git hooks to enforce policies ensures consistency and control your environment. Some of the practical uses are in enforcing preconditions for merging, verifying work item ID association in your commit message, preventing you and your team from committing faulty code, and sending notification to your team chat rooms like Teams, Slack, HipChats, etc. So where do I start? Let's start by exploring client-side Git hooks. You can navigate to repo.githooks directory. You will find that there is a bunch of samples, but they are disabled by default. For instance, if you open that folder, you will find a file called precommit.sample. To enable it, just rename it to precommit by removing the .sample extension and make the script executable. When you attempt to commit using git commit, the script is found and executed. If your pre-commit script exists with a 0, you commit successfully. Otherwise, the commit fails. That concludes this lesson. In this episode, we're going to look into how you can foster inner source. The fork-based pull request workflow is popular with open source projects since it allows anybody to contribute to a project. You don't need to be an existing contributor or have right access to a project to offer up your changes. This workflow isn't just for open source. Forks also help support inner source workflows within your company. Before forks, you have always been able to contribute to a project using pull request. The workflow is simple enough. You just need to push a new branch up to your repository and then open a pull request to get a code review from your team and have Azure Repos evaluate your branch policies. When your code is approved, you can click one button to merge your pull request into master and deploy. This workflow is great for working on your project with your team. But what if you notice a simple bug in a different project within your company and you want to fix it yourself? And what if you want to add a feature to your project that you use but another team develops? And that's where forks come in. Forks are the heart of inner source practices. Inner source, sometimes called internal open source, brings all the benefits of open source software development inside your firewall. It opens up your software development processes so that your developers can easily collaborate on projects across your company using the same processes that are popular throughout the open source software communities. But it keeps your code safe and secure within your organization. And Microsoft uses inner source approach heavily as part of the efforts to standardize on one engineering system throughout the company, backed by Azure Repos. And Microsoft has also opened up the source code of all their projects to everyone within the company. Now let's look into how can you implement the fork workflow. As discussed in the fork workflow, a fork is a copy of a repository. And forking a repository allows you to freely experiment with changes without affecting the original project. So let's look into what is fork. A fork starts with all the contents of its upstream repository. When you create a fork, you can choose whether to include all branches or limit to only the default branch. None of the permissions, policies, or build pipelines are applied. The new fork acts as if someone cloned the original repository, then pushed to a new empty repository. After a fork has been created, new files, folders, and branches are not shared between the repositories unless a pull request carries them along. How can you share code between forks? You can create PRs in each direction, from fork to upstream or upstream to fork. The most common direction will be from fork to upstream. The destination repository's permissions, policies, bills, and work items will apply to the PR. And how can you choose between branches and forks? If your repository has a large number of casual or infrequent committers, Microsoft recommends the forking workflow. Typically, only core contributors to your project have direct commit rights into your repository. You should ask contributors from outside the core set of people to work from a fork of the repository. This will isolate their changes from yours until you have had a chance to vet the work. Let's look at a forking workflow. The first step is to create a fork, then you clone it locally, then you make your changes locally and push them to a branch. And the fourth step is to create and complete a PR to upstream. And the final step is and sync your fork to the latest from upstream. How can you create a fork? You can navigate to the repository to fork and choose fork and specify a name and choose the project where you want the fork to be created. And if the repository contains a lot of topic branches, Microsoft recommends you fork only the default branch and choose the fork to create the fork. Please note that you must have the create repository permission in your chosen project to create a fork. And Microsoft recommends you create a dedicated project for forks where all contributors have the create repository permission. That concludes this lesson and module 3. In this episode, we're going to go through module 3 review questions. So without wasting any more time, let's get into it. Let's look at question number 1. Which repository type offers the benefits of reduced code complexity, effective code reviews, and sharing of common components? The correct answer is multiple repo. Let's look at question number 2. What are the 3 types of branching? You need to select 3 answers. The correct answers are trunk-based development, Git flow branching, and forking workflow. Question number 3. What are Git hooks? Git hook is a mechanism that allows arbitrary code to be run before or after and certain Git lifecycle events occur. Use Git hooks to enforce policies, ensure consistency, and control your environment can be either client-side or server-side. Let's look at question number 4. What are some of the best practices when working with files in Git? And what do you suggest for working with large files? The best practices you can use are use a package management system for DLLs, library files, and other dependent files, and doesn't commit the binaries, logs, tracing outputs, or diagnostic data from your builds. Don't commit large, frequently updated binary assets, and use different plain text format such as a JSON for configuration information. For large files, use Git LFS. That concludes module 3. In this episode, we're going to learn about packaging dependencies, which will include dependencies in software, why dependency management is needed, and elements of a dependency management strategy. So let us start with understanding what is dependency management. Modern software development involves complex projects and solutions. Projects have dependencies on other projects, and solutions are not single piece of software. The solutions and software built consist of multiple parts and components and are often reused. As code bases are expanding and evolving, it needs to be componentized to be maintainable. A team that is writing software will not write every piece of code by itself. They leverage existing code written by other teams or companies, or open source code that is readily available for them. Each component can have its own maintenance, speed of change, and distribution, giving both the creators and consumers of the components autonomy. A software engineer will need to identify the components that make up part of the solution and decide whether to write the implementation or include an existing component. The latter approach introduces a dependency on other components. So why is this dependency management needed? It is essential that the software dependencies that are introduced in a project and solution can be properly declared and resolved. You need to be able to manage the overall composition of project code and the included dependencies. Without proper dependency management, it will be hard to keep the components in the solution controlled. Now let us look at the elements of a dependency management strategy. There are a number of aspects for a dependency management strategy. They are standardization, package formats and sources, and versioning. So what is standardization? Managing dependencies benefit from a standardized way of declaring and resolving them in your code base. Standardization allows a repeatable, predictable process and usage that can be automated as well. Second dependency management strategy is package format and sources. The distribution of dependencies can be performed by a packaging method suited for the type of dependency in your solution. Each dependency is packaged using its applicable format and stored in a centralized source. Your dependency management strategy should include the selection of package formats and corresponding sources where to store and retrieve packages. The third one is versioning. Just like your own code and components, the dependencies in your solution usually evolve over time. While your code bases grow and changes, you need to take into account the changes in your dependencies as well. This requires a versioning mechanism for the dependencies so you can be selective of the particular version of the dependency you want to use. Let us look at how you can identify dependencies. It starts with identifying the dependencies in your code base and deciding which dependencies will be formalized. Your software project and its solutions probably already use dependencies. It is very common to use libraries and frameworks that are not written by yourself. Additionally, your existing code base might have internal dependencies that are not treated as such. For example, take a piece of code that implements certain business domain model. It might be included as source code in your project and also consumed in other projects and teams. You need to look into your code bases to identify pieces of code that can be considered dependencies to also treat them as such. This requires changes to how you organize your code and build the solution. It will bring your components together. Let's look at the two ways of componentization commonly used for. The first one is source componentization, and the second one is package componentization. So, what is source componentization? The first way of componentization is focused on source code. It refers to splitting up the source code in the code base in separate parts and organizing it around the identified components. It works as long as the source code is not shared outside of the project. Once the components need to be shared, it requires distributing the source code or the produced binary artifacts that are created from it. The second stage is package componentization. Distributing of software components is performed by means of packages as a formal way of wrapping and handling the components. A shift to packages adds characteristics needed for proper dependency management, like tracking and versioning of packages in your solution. Now let's look into identifying how can you decompose your system. Before you can change your code base into separate components to prepare for finding dependencies that can be taken out of your system, you will need to get better insight into your code and solution. This allows you to decompose your system to individual components and dependencies. The goal is to reduce the size of your own code base and system, making it more efficient to build and manageable in the end. You achieve this by removing certain components of your solution. These are going to be centralized, reused, and maintained independently. You will remove these components and externalizing them from your solution at the expense of introducing dependencies on other components. This process of finding and externalizing components is effectively called dependencies. It may require some refactoring, such as creating new solution artifacts for code organization or code changes to cater for unchanged code to take a dependency on an external component. You might need to introduce some code design patterns to isolate and include the componentized code. Decomposing could also mean that you will replace your own implementation of reusable code with an available open source or commercial component. Let us look at the different ways you can scan your code base for dependencies. There are a number of ways to identify the dependencies in your code base. These include scanning your code for patterns and reuse, as well as analyzing how the solution is composed of individual modules and components. The first way is finding the duplicate code. When certain pieces of code appear in several places, it is a good indication that this code can be reused. Keep in mind that code duplication is not necessarily a bad practice. However, if the code can be made available in a properly reusable way, it does have benefits over copying code and having to manage that. The first step to isolate these pieces of duplicate code is to centralize them in the code base and componentize them in the appropriate way for the type of the code. The second approach is to find code that might define components in your solution. You will look for code elements that have a high cohesion to each other and low coupling with other parts of code. This could be a certain object model and business logic, or code that is related because of its responsibility, such as a set of helper or utility code, or perhaps a basis of other code to be built upon. And the third method is finding the individual life cycle. Related to the high cohesion, You can look for parts of your code have a similar life cycle and can be deployed and released individually. If such code can be maintained by a team separate from the code base that it is currently in, it is an indication that it could be a component outside of the solution. Another method is looking for stable parts. Some parts of your code base might have a slow rate of change. That particular code is stable and is not altered often. You can check your code repository to find the code with a low change frequency. And the last method is looking for independent code and components. So, whenever code and components are independent and unrelated to other parts of your system, it can potentially be isolated to a separate component and dependency. That concludes this lesson. In this episode, we're going to learn about what is a package, types of packages, and what is private and public feeds. So let us start with understanding what is a package. Packages are used to define the components you rely and depend upon your software solution. They provide a way to store those components in a well-defined format with metadata to describe it. A package is a formalized way of creating a distributable unit of software artifacts that can be consumed from other software solutions. The package describes the component it contains and usually provides additional metadata. This additional information uniquely identifies the individual packages and to be self-descriptive. It helps to better store packages in centralized location and consumes the content of the package in a predictable manner. In addition, it enables tooling to manage the packages in the software solution. Let us look at the different types of packages. Packages can be used for a variety of components. The type of components you want to use in your code base differ for the different parts and layers of the solutions you are creating. Over the past years, the packaging format have changed and evolved. At the moment, there are a couple of de facto standard formats for packages. The first one is NuGet. NuGet packages is a standard used for .NET code artifacts. This includes .NET assemblies and related files, tooling, and sometimes only metadata. NuGet defines the way packages are created, stored, and consumed. A NuGet package is essentially a compressed folder structure with files in zipped format and has the .nubkg extension. Second type is NPM. An NPM package is used for JavaScript development. It originates from Node.js development, where it is the default packaging format. A NPM package is a file or folder that contains JavaScript files and a package.json file describing the metadata of the package. For Node.js, the package usually contains one or more modules that can be loaded once the package is consumed. Then we have Maven. Maven is used for Java-based project. Then we have PyPy, which is a Python package index. And Docker packages are called images and contain complete and self-contained deployments of components. Most commonly, a Docker image represents a software component that can be hosted and executed by itself without any dependencies on other images. Let's understand what is package feed all about and what is private and public feeds. Packages should be stored in a centralized place for distribution and consumption by others to take dependencies on the components it contains. The package feeds are centralized and available for many different consumers. Depending on the package, its purpose and origin, it might be generally available or to a selected audiences. Typically, open source projects for applications, libraries, and frameworks are shared to everyone and publicly available. The feeds can be exposed in public or private to distinguish its visibility. Public feeds can be consumed by anyone, and private feeds can only be consumed by those who are allowed to access. And each of these packages has corresponding manager that takes care of one or more of the following aspect of the package management: installation and removal of local packages, pushing packages to a remote package feed, consuming package from a remote package feed, searching feeds for packages, etc. And the package manager have cross-platform command line interface tools to manage the local packages and feed that host the packages. The CLI tooling is part of a local install on a development machine. So let's look at the packaging sources in detail. The various packaging types have a standard source that is commonly used for public use. It is a go-to place for developers to find and consume publicly available components as software dependencies. These sources are called package feeds, public feeds, and private feeds. So let us look into what are the common public package sources. In general, you will find the publicly available package sources are free to use. Sometimes they have a licensing or payment model for consuming individual packages or the feed itself. These public sources can be used to store packages you have created as part of your project. It does not have to be open source, although it is in most cases. Public and free package sources that offer feeds at no expense will usually require that you make the packages you store publicly available as well. The different types of package sources available are NuGet, NPM, Maven, Docker Hub, and Python. Now let us look at the private feed. Private feeds can be used in cases where packages should be available to a selected audience. The main difference between public and private feed is the need for authentication. Public feeds can be anonymously accessed and optionally authenticated, wherein private feeds can be accessed only when authenticated. There are two options for private feeds: self-hosting and SaaS services. In self-hosting, some of the package managers are also be able to host a feed. Using on-premises or private cloud resources, one can host the required solution to offer a private feed. In SaaS services, a variety of third-party vendors and cloud providers offer software as a service feed that can be kept privately. This typically requires a consumption fee or cloud subscription. This is a following table that contains a non-exhaustive list of self-hosting options and SaaS offering to privately hosted package feeds. Now let us discuss how can you consume these packages. Each software project that consumes packages to include the required dependencies will need to use the package manager and one or more package sources. So we have two models, upstream sources and packages graph. Upstream sources, one way to specify multiple package sources is by choosing a primary source and specifying an upstream source. The package manager will evaluate the primary source first and switch to the upstream source when the package is not found there. The upstream source might be one of the official public source or private source. The upstream source could refer to another upstream source itself or creating a chain of sources. Now let's discuss the package graph. A feed can have one or more upstream sources, which might be internal or external. Each of these can have additional upstream sources as well. A feed can have one or more upstream sources, which might be internal or external. Such graph can offer many possibilities for layering and indirection of origins of packages. This might fit well with multiple teams taking care of packages for frameworks and other base libraries. The downside of that package graphs can become complex when not properly understood or designed. It is important to understand how you can create a proper package graph. Let's look into Azure artifacts now. Previously, we have learned about packaging dependencies and various packaging formats, feeds, sources, and package managers. Now we will learn more about package management and how to create a feed and publish packages to it. Microsoft Azure DevOps provide various features for application lifecycle management, including work item tracking, source code repositories, build and release pipelines, and artifact management. The artifact management is called Azure Artifacts and was previously known as package management. It offers public and private feeds for software packages of various types. Azure Artifacts currently supports feed that can store 5 different package types: NuGet packages, NPM packages, Maven, universal packages, and Python. A single Azure Artifacts feed can contain only combination of such packages, and you can connect to the feed using the package managers and the corresponding tooling for the package types. That concludes this episode and Module 4. In this episode, we're going to look into Module 4 Knowledge Check. So without wasting any more time, let's get into it. Let's look at the first question. If you are creating a feed that will allow yourself and those that you invite to publish, what visibility should you choose? The correct answer is private. Question number 2. Can you create a package feed for Maven in Azure Artifacts? The answer is yes. Question number 3. What type of package should you use for machine learning training data and models? The correct answer is universal. Question number 4. If an existing package is found to be broken or buggy, how should it be fixed? The correct answer is publish a new version. Question number 5. What is meant by saying that a package should be immutable? The correct answer is a published version should never be changed, only replaced by a later version. That concludes Module 4. In this episode, we're going to learn about the concept of pipelines in DevOps, which includes build automation and continuous integration, test automation, deployment automation, etc. Now let us start with understanding the concept of pipelines in DevOps. The core idea is to create a repeatable, reliable, and incrementally improving process for taking software from concept to customer. The goal of it is to enable a constant flow of changes into production via an automated software production line. Think of this as a pipeline. The pipeline breaks down the software delivery process into stages. Each stage is aimed at verifying the quality of new features from a different angle to validate the new functionality and prevent errors from affecting your users. The pipeline should provide feedback to the team and visibility into the flow of changes to everyone involved in delivering the new features. A typical pipeline will include the following stages: build automation and continuous integration, test automation, and deployment automation. Now let us look into what is build automation and continuous integration. The pipeline starts by building the binaries to create the deliverables that will be passed to the subsequent stages. New features implemented by the developers are integrated into the central code base on a continuous basis, built and unit tested. This is the most direct feedback cycle that informs the development team about the health of their application's code. The second stage is test automation. Throughout this stage, the new version of an application is rigorously tested to ensure that it meets all desired system qualities. It is important that all relevant aspects, whether functionality, security, performance, or compliance, are verified by the pipeline. The stage may involve different type of automated or initially at least manual activities. And the third stage is deployment automation. A deployment is required every time the application is installed in an environment for testing. But the most critical moment for deployment automation is rollout time. Since the preceding stages have verified the overall quality of the system, this is a low-risk setup. The deployment can be staged, with the new version being initially released to a subset of the production environment and monitored before being completely rolled out. The deployment is automated, allowing for reliable delivery of new functionality to users within minutes if needed. And your pipeline needs platform provisioning and configuration management. The deployment pipeline is supported by platform provisioning and system configuration management, which allows teams to create, maintain, and tear down complete environments automatically or at the push of a button. The next stage is orchestrating it all, which means release and pipeline orchestration. The multiple stages in a deployment pipeline involve different groups of people collaborating and supervising the release of the new version of your application. Release and pipeline orchestration provides a top-level view of the entire pipeline, allowing you to define and control the stages and gain insight into the overall software delivery process. By carrying out value stream mappings on your releases, you can highlight any remaining inefficiencies and hotspots and pinpoint opportunities to improve your pipeline. These automated pipelines need infrastructure to run. The efficiency of this infrastructure will have a direct impact on your effectiveness of the pipeline. That concludes this lesson. In this episode, we're going to learn about Azure pipelines. Within it, we are going to discuss, does Azure pipeline work with my languages and tools, different types of version control systems, application types, deployment targets, etc. So what is Azure pipelines? Azure Pipeline is a cloud service that you can use to automatically build and test your code project and make it available to other users. It works with just about any language or project type. And Azure Pipelines combines continuous integration and continuous delivery to constantly and consistently test and build your code and ship it to any target. So let's look into, does Azure Pipeline work with your language and tools? Like I said, Azure Pipeline is a fully featured cross-platform CI/CD service, and it works with your preferred Git provider and can deploy to most major cloud services, which include Azure services as well. So let's look into what are the languages which are supported. You can use many languages with Azure Pipeline, such as Python, Java, Ruby, PHP, C Sharp, and Go. What about version control systems? Before you use continuous integration and continuous delivery practices for your application, you must have your source code in a version control system. Azure Pipelines integrates with GitHub, GitLab, Azure Repos, Bitbucket, and Subversion. And what about application types? You can use Azure Pipeline with most application types such as Java, JavaScript, Python, .NET, PHP, Go, Xcode, and C++. What about deployment targets? You can use Azure Pipelines to deploy your code to multiple targets, and the target include container registries, virtual machines, Azure services, or any on-premises or cloud target such as Microsoft Azure, Google Cloud, or Amazon Cloud Services. What about package formats? To produce packages that can be consumed by others, you can publish NuGet, NPM, or Maven packages to the built-in package management repository in Azure Pipelines. You also can use any other package management repository of your choice. You might wonder, why should you use CI and CD and Azure Pipelines? Implementing CI and CD pipelines help to ensure consistent and quality code that are readily available to users. Azure Pipelines is a quick, easy, and safe way to automate building your projects and making them available to users. Continuous integration is used to automate test and build for your project. CI helps to catch bugs or issues early in the development cycle when they are easier and faster to fix. Items known as artifacts are produced from CI systems. They are used by the continuous delivery release pipelines to drive automatic deployments. Continuous delivery is used to automatically deploy and test code in multiple stages to help drive quality. And continuous integration systems produce deployable artifacts, which includes infrastructure and apps. Automated release pipelines consumes these artifacts to release new versions and fixes to the target of your choice. Now let us understand different basic terms and parts of Azure Pipeline, which helps you further explore how it can help you deliver better code more efficiently and reliably. Let us start with understanding what is agent. When your build or deployment runs, the system begins one or more jobs. An agent is installable software that runs one build or deployment job at a time. What is artifact? An artifact is a collection of files or packages published by a build, and artifacts are made available to subsequent tasks such as distribution or deployment. The next one is build. A build represents one execution of a pipeline. It collects the logs associated with running the steps and the results of running test. The next term we are going to understand is continuous delivery or CD. Continuous delivery is a process by which code is built, tested, and deployed to one or more test and production stages. Deploying and testing in multiple stages helps drive quality. Continuous integration systems produce deployable artifacts, which include infrastructure and apps. Automated release pipeline consume these artifacts to release new versions and fixes to existing systems. Monitoring and alerting systems run constantly to drive variable into the existing CD process. This process ensures that errors can caught often and early. The next term we are going to learn is continuous integration or CI. Continuous integration is the practice used by development teams to simplify the testing and building of code. And CI helps to catch bugs or problems early in the development cycle, which makes them easier and faster to fix. Automated tests and builds are run as part of CI processes. The process can run on a set schedule whenever code is published or both. Items known as artifacts are produced from CI systems. They are used by the continuous delivery release pipelines to drive automatic deployments. The next term we are going to learn is called deployment target. A deployment target is a virtual machine, container, web app, or any service that used to host application being developed. A pipeline might deploy the app to one or more deployment targets after build is completed and tests are run. Let's look at the next term, which is called job. A build contains one or more jobs. Each job runs on an agent. A job represents an execution boundary of a set of steps. All of the steps run together on the same agent. For example, you might build two configurations, maybe for an x86 and x64. In this case, you have one build and two jobs. The next term is pipeline. A pipeline defines the continuous integration and deployment process for your app. It's made up of steps called tasks, and it can be thought of as a script that defines how your test, build, and deployment steps are run. The next term is release. When you use the Visual Designer, you create a release pipeline in addition to a build pipeline. A release is the term used to describe one execution of the release pipeline. It's made up of deployments to multiple stages. The next term is called task. A task is the building block of a pipeline. For example, a build pipeline might consist of build task and test task. A release pipeline consists of deployment task, and each task runs a specific job in the pipeline. And finally, what is trigger? A trigger is something that's set up to tell the pipeline when to run. You can configure a pipeline to run upon a push to a repository at scheduled times or upon the completion of another build. All of these actions are known as triggers. That concludes this episode. In this episode, we're going to learn about evaluating use of hosted versus self-hosted agents. Within this, we will learn about Microsoft versus self-hosted agents and agents pools, etc. So let's look into Microsoft versus self-hosted agents. To build your code or deploy your software, you need at least one agent. As you add more code and people, you will eventually need more. When your build or deployment runs, the system begins one or more jobs. An agent is installable software that runs one build or deployment job at a time. Now let us look into the two types of agents. Microsoft hosted agents, and self-hosted agents. So what is this Microsoft hosted agents? If your pipeline are in Azure pipelines, then you have got a convenient option to build and deploy using Microsoft hosted agent. With Microsoft hosted agents, maintenance and upgrades are taken care for you. Each time you run a pipeline, you get a fresh virtual machine. The virtual machine is discarded after one use. For many teams, this is the simplest way to build and deploy, and you can try it first and see it if it works for your build or deployment. If not, you can use a self-hosted agent. So what is self-hosted agents? An agent that you set up and manage on your own to run build and deployment jobs is a self-hosted agent. You can use self-hosted agents in Azure pipelines, and self-hosted agents give you more control to install dependent software needed for your builds and deployments. You can install the agent on Linux, Mac OS, and Windows machines. You can also install an agent on a Linux Docker container. After you have installed the agent on a machine, you can install any other software on that machine as required by your build or deployment jobs. Now let us look into agent pools. So what is an agent pool? Instead of managing each agent individually, you organize agents into agent pools. An agent pool defines the sharing boundary for all agents in that pool. In Azure pipelines, agent pools are scoped to the Azure DevOps organization. So you can share an agent pool across projects. A project agent pool provides access to an organization agent pool. When you create a build or release pipeline, you specify which pool it uses. And pools are scoped to your project, so you can only use them across build and release pipelines within a project. To share an agent pool with multiple projects, in each of those projects, you create a project agent pool pointing to an organization's agent pool. While multiple pools across projects can use the same organization agent pool, multiple pools within projects cannot use the same organization agent pool. Also, each project agent pool can use only one organization agent pool. And these are the list of organization agent pools provided by default for you. Each of these Microsoft hosted organization agent pool is exposed to each project through a corresponding project agent pool. By default, all contributors in a project are members of the user role on each hosted pool. This allows every contributor in a project to author and run build and release pipelines using Microsoft hosted pools. Let's look at the typical situations for agent pools. If you have got a lot of agents intended for different teams or purposes, you might want to create additional pools as mentioned here. So let's look at some of the typical scenarios when you might want to create additional agent pools. If you are a member of a project and you want to use a set of machines owned by your teams for running build and deployment jobs, then you first make sure you are the member of the group in all pools with the administrator role. The second scenario is if you are a member of an infrastructure team and would like to set up a pool of agents for use in all the projects. And third scenario is you want to share a set of agent mechanisms with multiple projects, but not all of them. Let's understand how security works for agent pools, which helps you control sharing and use of agents. In Azure Pipeline, roles are defined on each agent pool, and membership in these roles governs what operations you can perform on an agent pool. The first one is reader. Members of this role can view the organization agent pool as well as agents. You typically use this to add operators that are responsible for monitoring the agent and their health. The second role is service account. Members of this role can use the organization agent pool to create a project agent pool in a project. And the third one is administrator. In addition to all the above permissions, members of this role can register and unregister agents from the organization's agent pool. They can also refer to the organization's agent pool when creating a project agent pool in a project. Alright, so that concludes this lesson. In this episode, we're going to look into pipelines and concurrency. Within this, we're going to learn about Microsoft hosted CI CD, self hosted CI CD, parallel jobs, etc. So let's look into Microsoft hosted versus self hosted. One parallel job in Azure pipeline will let you run a single build or release job at any given time. This rule is true whether you run a job on Microsoft hosted or self hosted agents. So, first, let's understand Microsoft hosted CI CD. If you want to run your build and releases on machines that Microsoft manages, use Microsoft hosted parallel jobs. Your jobs run on the pool of hosted jobs. And Microsoft provide a free tier of service by default for every organization. For public project, 10 free Microsoft hosted parallel jobs can run for up to 360 minutes, which is around 6 hours each time, with no overall time limit per month. For a private project, one free parallel job that can run up to 30 minutes each time until you have used 1800 minutes, which is around 30 hours per month. When the free tier is no longer sufficient, you can contact Microsoft to get your free tier limits increased. So, what about self hosted CI CD? If you want Azure pipelines to orchestrate your build and releases, but use your own machines to run them, use self hosted parallel jobs. You start by deploying agents on your machines, and you can register any number of these self hosted agents in your organization. Microsoft charges based on the number of jobs you want to run at a time, not the number of agents registered. And Microsoft provide a free tier of service by default in every organization. For a public project, 10 free self-hosted parallel jobs are free. For private project, one self-hosted parallel job. Additionally, for every active Visual Studio plus enterprise subscriber who is a member of your organization, you get one additional self-hosted parallel job as well. When the free tier is no longer sufficient, you can contact Microsoft for free tier limits increased. There is no time limit on self-hosted jobs. Now let's look into parallel jobs. Consider an organization that has only one Microsoft hosted parallel job. This job allows users in that organization to collectively run only one build or release job at a time. When additional jobs are triggered, they are queued and will wait for the previous job to finish. A release consumes a parallel job only when it's been actively deployed to a stage. While the release is waiting for an approval or a manual intervention, it does not consume a parallel job. So, how can you estimate parallel jobs? First, you need to determine how many parallel jobs you need. You can begin by seeing if the free tier offered in your organization is enough for your teams. When you have reached the 1800 minutes per month for the free tier of Microsoft hosted parallel job, you can start by buying one parallel job to remove this monthly time limit before deciding to purchase more. And what is a simple estimate? A simple rule of thumb is estimate that you will need one parallel job for every 4 or 5 users in your organization. And you can view parallel jobs by browsing to your organization settings, pipelines, retention and parallel jobs, and parallel jobs. This is where you can view the minimum number of parallel jobs that are available in your organization. That concludes this lesson. In this episode, we're going to look into Azure DevOps and open source projects. Within this, we will discuss about public versus private projects, supported services, and a practical example with .NET Core CLI. So let's understand what is Azure DevOps and open source projects. Azure DevOps offers a suite of DevOps capabilities to developers, including source control, agile planning, build, release, test, and more. But to use Azure DevOps feature require the user to first log in using a Microsoft or GitHub account. This, however, blocks a lot of interesting scenarios when you would want to share your code and artifacts publicly, or simply providing a wiki library or build status page for unauthenticated users. Let us discuss what is public versus private projects. Projects in Azure DevOps provide a repository for source code and a place for a group of developers and teams to plan, track progress, and collaborate on building software solutions. One or more projects can be defined within an organization in Azure DevOps. Users that aren't signed into the service have read only access to the public project on Azure DevOps. And private projects, on the other hand, require users to be granted access to the project and signed in to access the services. Now, let us look into the supported services. Non-members of a public project will have a read-only access to a limited set of services. Specifically, browse the code base, download code, view commits, branches, and pull requests. You can only view and filter work items, view a project page or dashboard, view the project wiki, and perform semantic search of the code or work items. And the last is, and now let us look into a practical example with .NET Core CLI. Supporting open source development is one of the most compelling scenarios for public projects. A good example is the .NET Core CLI. Their source is hosted on GitHub and they use Azure DevOps for their CI builds. However, if you click on the build badges in their README, unless you were one of the maintainers of the project, you will not be able to see the build results. Since this is an open source project, everybody should be able to view the full result so they can see why a build failed and maybe even send a pull request to help fix it. Thanks to public project capabilities, the team will be able to enable just that experience, and everyone in the community will have access to the same build results, regardless of if they are a maintainer on the project or not. Now, let us look into some of the questions you might ask. How do you qualify for the free tier of Azure Pipeline for public projects? Microsoft will automatically apply the free tier limits for public project if you meet both of these conditions. The conditions are your pipeline, if your pipeline is part of an Azure Pipelines public project, or your pipeline builds a public repository for GitHub or from the same public projects in your Azure DevOps organization. Second question is, are there limits on who can use Azure Pipelines? You can have as many users as you want when you are using Azure Pipelines. There is no per user charge for using Azure Pipelines. And users with both basic and stakeholder access can author as many builds and releases as they want. Third question is, are there any limits on the number of builds and release pipelines that I can create? No. You can create hundreds or even thousands of definitions for no charge. You can register any number of self-hosted agents for no charge. Fourth question is, as a Visual Studio Enterprise subscriber, do I get additional parallel jobs for TFS and Azure pipelines? Yes. Visual Studio Enterprise subscribers get one parallel job in Team Foundation Server 2017 or later, and one self-hosted parallel job in each Azure DevOps service organization where they are a member. Another question is, what about the option to pay for hosted agents by the minute? Some of Microsoft earlier customers are still on per minute plan for the hosted agents. In this plan, you pay $0.05 per minute for first 20 hours after the free tier and $0.01 per minute after 20 hours. Because of the following limitations in this plan, you might want to consider moving to the parallel job model. That concludes this lesson. In this episode, we're going to learn about Azure Pipelines and YAML versus Visual Designers. Within that, we're going to look into use Azure Pipelines with YAML and benefits of using YAMLs, etc. Azure DevOps offers you both experiences. You can either use YAML to define your pipelines or use the Visual Designer to do the same. You will, however, find that there are more product level investments being made to enhance the YAML pipeline experience. When you use YAML, you define your pipeline mostly in code alongside the rest of the code for your app. When you use the Visual Designer, you define a build pipeline to build and test your code and then to publish artifacts. You also define a release pipeline to consume and deploy these artifacts to deployment targets. You can configure your pipeline in YAML file that exists alongside your code, which include configuring Azure Pipeline to use your Git repo, edit your Azure Pipeline YAML files to define your build, push your code to your own version control repository. This action kicks off the default trigger to build and deploy, then monitor the results. Then your code is now updated, built and tested and packaged, and it can be deployed to any target. So, what are the benefits of using YAML? If you use YAML, the pipeline is versioned with your code and follows the same branching structure. You get validation of your changes through code reviews in pull requests and branch build policies. Another benefit is every branch you can modify the build policy by modifying the Azure Pipelines.yaml file. Now let us look into Azure Pipelines and Visual Designer. You can create and configure your build and release pipeline in Azure DevOps web portal with the Visual Designer. And you can configure Azure Pipelines to use your Git repos as well. First is you use your Azure Pipeline Visual Designer to create and configure your build and release pipeline. Then you will push your code to your version control repository. This action triggers your pipeline and run tasks such as building or testing code. Then build, create, and artifacts that is used by the rest of your pipeline to run tasks such as deploying to staging or production. And finally, your code is now updated, built, tested, and packaged, and it can be deployed to any target. So, what are the benefits of using the Visual Designer? The Visual Designer is great for users who are new to the world of continuous integration and continuous delivery. The visual representation of the pipelines makes it easier to get started, and the Visual Designer is located in the same hub as the build results. This location makes it easier to switch back and forth and make changes. That concludes this lesson. In this episode, we're going to learn about continuous integration overview. Within that, we will go through 4 pillars of continuous integration, benefits, etc. So, what is continuous integration? Continuous integration, or CI, is the process of automating the build and testing of code every time a team member commits changes to version control. Continuous integration encourages developers to share their code and unit test by merging their changes into a shared version control repository after every small task completion. Committing code triggers an automated build system to grab the latest code from the shared repository and to build, test, and validate the full master branch, also known as the trunk or main. The idea is to minimize the cost of integration by making it an early consideration. And developers can discover conflicts of the boundaries between new and existing code early, while conflicts are still relatively easy to reconcile. Once the conflict is resolved, work can continue with confidence that the new code honors the requirement of the existing code base. The end goal of continuous integration is to make integration a simple, repeatable process that is part of everyday development workflow in order to reduce integration cost and respond to defects early. Working to make sure the system is robust, automated, and fast while cultivating a team culture that encourages frequent interaction and responsiveness to build issues is fundamental to the success of the strategy. Now let us look into the 4 pillars of continuous integration. This continuous integration relies on 4 key elements for successful implementation: a version control system, a package management system, a continuous integration system, and an automated build process. A version control system manages changes to your source control over time, which include Git, Apache Subversion, Team Foundation version control, etc. A package management system is used to install, uninstall, and manage software packages. This include NuGet, Node Package Manager, Chocolatey, Homebrew, RPM, etc. The third pillar is continuous integration system. A continuous integration system merges all developer working copies to a shared mainline several times a day. This includes Azure DevOps, TeamCity, and Jenkins. And the fourth pillar is automated build process. An automated build process creates a software build including compiling, packaging, and running automated tests. This includes Apache Ant, Enant, and Gradle. Please note that for each element, your team need to select a specific platform and tools they will use, and you must ensure that you have established each pillar before proceeding. So what are the benefits of continuous integration? Continuous integration provides many benefits for deployment process. This include improving your code quality, triggering automated testing for every code change, reducing build time, better managing in technical debt, reducing long and difficult bug-inducing merges, and increasing confidence in your code base. Possibly the most important benefit of continuous integration is rapid feedback to the developer. If the developer commits something and it breaks the code, he or she will know that almost immediately from the build, unit test, and through other metrics. If successful integration is happening across the team, the developer is also going to know if their code change breaks something that another team member did it in a different part of their code base. This process removes very long, difficult, and drawn out bug inducing merges, which allows organizations to deliver in a very fast cadence. This example shown here is from the build option that were configured by the ASP.NET Web Application Build template. In this case, the date has been retrieved as a system variable, then formatted via year, month, and date, and the revision is then appended. This is an example of a build can be automatically triggered. This is a key capability required for continuous integration. But there are times that you might not want the build to run even if it is triggered. This can be controlled with these settings. The authorization scope determines whether the build job is limited to accessing resources in the current project or if it can access resources in other projects in the project collection as well. The build job cancel timeout determines how long the server will wait for the build job to respond to a cancellation request. And some development teams like to show the state of the build on an external monitor or website. These settings provide a link to the image to use for that. This is an example of the Azure Pipeline badge that has succeeded. That concludes this lesson. In this episode, we're going to look into implementing a build strategy, which include configuring agent demands as well. So let's look into how you can configure agent demands. Not all agents are same. So we have seen that they can be based on different operating system, but they can also have different dependencies installed. To describe this, every agent has a set of capabilities configured as name-value pairs. The capabilities such as machine name and type of operating system that are automatically discovered as referred as system capabilities. The ones that you define are called user capabilities. On the agent pools page at the organization level, when you select an agent, there is a tab for capabilities. You can use it to see the available capabilities for an agent and to configure user capabilities. Let's look at implementing multi-agent builds. You can use multiple build agents to support multiple build machines, either to distribute the load or to run build in parallel or to use different agent capabilities. As an example, components of an application might require different incompatible versions of a library or dependency. Adding multiple jobs in a pipeline lets you break your pipeline into sections that need different agent pools or self-hosted agents. And this will help you publish artifacts in one job and consume them in one or more subsequent jobs. This helps you build faster by running multiple jobs in parallel and enable conditional execution of tasks as well. To add another agent job to an existing pipeline, you can click on this ellipsis. And what about parallel job? At the organization level, you can configure the number of parallel jobs that are made available. The free tier allows for one parallel job or up to 1800 minutes per month. The self-hosted agent has higher levels. Please note that you can define a build as a collection of jobs rather than a single job. Each job consumes one of these parallel jobs that runs on an agent. If there aren't enough parallel jobs available for your organization, the jobs will be queued and run sequentially. That concludes this lesson. In this episode, we're going to look into an anatomy of a pipeline. Azure pipelines can automatically build and validate every pull request and commit to your Azure Repos Git repository. And Azure pipelines can be used with Azure DevOps public project as well as Azure DevOps private projects. So let me show you an example by creating a Hello World YAML pipeline. So let's create a simple pipeline that echoes Hello World. No technical course is complete without a Hello World example. And most pipeline will have these components. The first component is name. Sometimes this is often be skipped. If it is skipped, a date-based name is generated automatically. The next component is trigger. Without an explicitly trigger, there is an impact trigger on every commit from any branch in this repo. Another component is variables. These are inline variables. Another component is job. Every pipeline must have at least one job. Fifth component is pool. You configure which pool the job must run on. Then we have checkout. The checkout self tells the job which repository to check out for this job. And finally, we have steps, the actual task that needs to be executed. In this case, a script task that can run inline scripts. Now let us look into this detail. First, name. The variable name is a bit misleading. Since the name is really the build number format, if you do not explicitly set a name format, you will get an integer number. This is a monotonically increasing number for run triggered off this pipeline starting at 1. The number is stored in Azure DevOps, and you can make use of this number by referencing to $rev. To make date-based number, you can use this format, and to get a build number like this, to get a semantic number like 1.0.x, and you can use something like this version number. Then we have trigger. If there is no explicit trigger sections, then it is implied that any commit to any path in any branch will trigger this pipeline to run. And you can be more explicit, though using filters such as branches and or path. The trigger is configured to queue the pipeline only when there is a commit to the master branch. Then we have jobs. A job is a set of steps that are executed by an agent in a queue or pool. And jobs are atomic. They are executed wholly on a single agent. And you can configure the same job to run on multiple agents at the same time. But even in this case, the entire set of steps in the job are run on every agent. And if you need some steps to run on one agent and some on another, you will need 2 jobs. And the job will have these following list of attributes. Display name is a friendly name. Depends on is a way to specify dependencies on ordering of multiple jobs. Condition is a binary expression. Strategy is used to control how jobs are parallelized. Continue on error is to specify if the remainder of the pipeline should continue or not if the job fails. Pool is the name of the pool or the queue to run the job on. Workspace is managing the source workspace. Container is for specifying a container image to execute the job in. And variables is where variables are scoped for this job. Steps is the set of steps to execute. Then we have timeout in minutes and services. Now let's look into dependencies. You can define dependencies between job using depends on property. This lets you specify sequences and fan out and fan in scenarios. If you do not explicitly define a dependency, a sequential dependency is implied. If you truly want job to run in parallel, you need to specify depends on as none. The next one is checkout. Classic builds implicitly check out any repository artifacts, but pipelines require you to be more explicit using checkout keyword. And downloading artifacts require you to use the download keyword. And downloads also work the opposite way for jobs and deployment jobs. The next is resources. And what if your job requires source code in another repository? You will need to use resources, and resources let you reference other repositories, pipelines, builds, containers, and packages. Next one is steps and tasks. Steps are the actual thing that executes in the order that they are specified in the job. Each step is a task. There are out-of-box tasks that comes with Azure DevOps, and many of which are aliases, and there are tasks that get installed on Azure DevOps account via the marketplace. The next one is variables. It would be tough to achieve any sort of sophistication in your pipeline without variables. There are several types of variables. And finally, we have pipeline structure. A pipeline is one or more stages that describe CI/CD process. Stages are the major divisions in the pipeline. A stage is one or more jobs which are units of work assignable to the same machine. You can arrange both stages and jobs into dependency graphs. A job is a linear series of steps, and steps can be tasks, scripts, or references to external templates. This is an example of a hierarchy which is reflected in the structure of a YAML file like. That concludes this lesson. In this episode, we're going to look into setting up private agents. Let's start with understanding the communication with Azure Pipeline. The agent communicates with Azure Pipelines to determine which job it needs to run and to report the logs and job status. This communication is always initiated by the agent. All the messages from the agent to Azure Pipelines are over HTTPS. Depending on how you configure the agent, the pull model allows the agent to be configured in different topologies as shown in this example here. Let's look into communication to deploy to target servers. When you use the agent to deploy the artifacts to a set of servers, it may have a line of sight connectivity to those servers. The Microsoft hosted agent pools by default have connectivity to Azure websites and servers running in Azure. If your on-premises environments do not have connectivity to an Azure hosted agent pool, you will need to manually configure a self-hosted agent on on-premises computers. The agent must have connectivity to the target on-premises environments and access to the internet to connect to Azure Pipelines or Team Foundation server, as shown in this picture here. So what are the other considerations? The first one is authentication. To register an agent, you need to be a member of the administrator role in the agent pool. The identity of agent pool administrator is needed only at the time of registration and is not persisted on the agent and is not used by any subsequent communication between the agent and Azure Pipelines. In addition, you must be a local administrator on the server in order to configure the agent. And your agent can authenticate to Azure Pipeline or TFS using one of the following methods. You can either use Personal Access Token or PAT. You can use this to generate and use PAT to connect an agent with Azure Pipelines. PAT is the only scheme that works with Azure Pipeline. The next one is interactive versus service. You can run your agent as either a service or an interactive process. Whether you run the agent as a service or interactively, You can choose which account you use to run the agent. Let's talk about agent version and upgrades. Microsoft updates the agent software every few weeks in Azure Pipeline. The agent version is indicated in the format major and minor. For instance, if the agent version is 2.1, then the major version is 2 and the minor version is 1. When a newer version of the agent is only different in minor version, it is automatically upgraded by Azure Pipelines. This upgrade happens when one of the tasks requires a newer version of the agent. If you run the agent interactively, or if there are newer major versions of the agent available, then you have to manually upgrade the agents. You can do this easily from the agent pools tab under the project collection or organization. That concludes this lesson. In this episode, we're going to go through Module 5, Knowledge Check. Let's look at the first question. What are some of the advantages of Azure Pipeline? Mark all that apply. So the correct answer is all of the options mentioned here. You can use Azure Pipeline, which can work with any platform, including Python, Java, PHP, Ruby, C Sharp, and Go. It can work with open source projects. You can deploy to different types of target at the same time. Azure Pipeline can be integrated with Azure deployments. And Azure Pipelines built on Windows, Linux, and Mac machines and integrated with GitHub as well. Question number 2. What is a pipeline and why is it used? A pipeline enables a constant flow of changes into production via an automated software production line, and pipelines create a repeatable, reliable, and incrementally improving process for taking software from concept to customer. Let us look into question number 3. What is an agent pool and why would you use it? The correct answer is you can organize agents into agent pools. An agent pool defines the sharing boundary. In Azure Pipeline, agent pools are scoped to Azure DevOps organization. So you can share an agent pool across projects. Question number 4. Name 2 ways to configure your Azure pipelines. The correct answer is Visual Designer and using YAML file. Question number 5. Name the 4 pillars of continuous integration. The correct answer is a version control system, package management system, continuous integration system, and automated build process. Question number 6. You want to take your build server offline to make a configuration change, and you want it to complete any build that it is currently processing. But you want to queue any new build request as well. What should you do? The correct answer is you should pause the build. A paused build will not start new builds and will queue any new build request. Let's look at question number 7. You want to set a maximum time that builds can run for, and builds should not run for more than 5 minutes. What configuration change should you make? The correct answer is you should change the build job timeout setting to 5 minutes. A blank value means unlimited. That concludes Module 5. In this episode, we're going to learn about Introduction to DevOps Security. With continuous integration and continuous delivery, how do you ensure your applications are secure and stay secure? And how do you find and fix security issues early in the process? This begins with practices commonly referred as DevSecOps. DevSecOps incorporates the security team and their capabilities into your DevOps practices, making security a responsibility of everyone on the team. Securing application is a continuous process that encompasses secure infrastructure, designing an architecture with layered security, and continuous security validation and monitoring for attacks. And security is everyone's responsibility and needs to be looked at holistically across the application lifecycle. So let's learn about what is SQL injection attack. SQL injection is a type of an injection attack that makes it possible to execute malicious SQL statements. These statements control a database server behind a web application. Attackers can use SQL injection vulnerabilities to bypass application security measures. They can go around authentication and authorization of a web page or web application and retrieve the content of the entire SQL database. They can also use SQL injection to add, modify, and delete records in the database. An SQL injection vulnerability may affect any website or web application that uses an SQL database such as MySQL, Oracle, SQL Server, or others. Criminals may use it to gain unauthorized access to your sensitive data, customer information, personal data, trade secrets, intellectual property, and more. And SQL injection attacks are one of the oldest, most prevalent, and most dangerous web application vulnerabilities. Now let's learn about how to implement secure and compliant development process. First, let's look into threat modeling. Threat modeling is a core element of the Microsoft security development lifecycle. It's an engineering technique you can use to help you identify threats, attacks, vulnerabilities, and countermeasures that could affect your application. You can use threat modeling to shape your application's design, meet your company's security objectives, and reduce risk. There are five major threat modeling steps. It starts with defining security requirements, creating an application diagram, identifying threats, mitigating threats, and the fifth one is validating that threats have been mitigated. And the threat modeling should be part of your routine development lifecycle, enabling you to progressively refine your threat models and further reduce risk. The Microsoft Threat Modeling tool makes threat modeling easier for all developers through a standard notation of visualizing system components, data flows, and security boundaries. Now let's look into key validation points. Continuous security validation should be added at each step from development through production to help ensure that application is always secure. The goal of this approach is to switch the conversation with the security team from approving each release to approving the CI/CD process and having the ability to monitor and audit the process at any time. This diagram highlights the key validation points in CI/CD pipeline. Depending on your platform and where your application is at in its life cycle, you may need to consider implementing the tools gradually, especially if your product is mature and you haven't previously run any security validation against your site or application. Now let's look into infrastructure vulnerabilities. In addition to validating the application, the infrastructure should also be validated to check for any vulnerabilities. When using the public cloud such as Azure, deploying the application and shared infrastructure is easy. So it's important to validate that everything has been done securely. Azure includes many tools to help report and prevent these vulnerabilities, including Security Center and Azure policies. Also, we have set up a scanner that can ensure any public endpoints and ports have been whitelisted, or else it will raise infrastructure issues. This is run as part of the network pipeline to provide immediate verification, but it also needs to be executed each night to ensure that there aren't any resource publicly exposed that should not be. The application CI/CD pipeline should run within a few minutes, so you don't want to include any long running processes. The baseline scan is designed to identify vulnerabilities within a couple of minutes, making it a good option for the application CI/CD pipeline. This example outlines the step for both the application CI/CD pipeline and the longer running nightly OSWAP ZAP pipeline. Once the scans have completed, the Azure pipeline release is updated with a report that includes the results and bugs are created in the team's backlog. Resolved bugs will close if the vulnerability has been fixed and move back into the in progress if the vulnerability still exists. The benefit of using this is that the vulnerabilities are created as bug that provides actionable work that can be tracked and measured. That concludes this lesson. In this episode, we're going to learn about rethinking application configuration data. In recent years, we have seen a shift around following some great practices around effective DevOps and some great tools like Chef, Puppet for managing configuration for different languages. While these have helped to inject values during CI/CD pipeline and greatly simplified the management of configuration, the blah.config concept has not completely moved away. Frameworks like ASP.NET support the notion of app setting JSON across environment, and the framework has made it very effective to use these across environments through interfaces like iHosting environment and iConfiguration. But we can do better. One of the key reasons we would want to move the configuration away from the source control is to delineate responsibilities. So let's look at these new concepts. The first one is configuration custodian. So configuration custodian is responsible for generating and maintaining the lifecycle of the configuration values. These include CRUD on keys, ensuring the security of secrets, regeneration of keys and tokens, and defining configuration settings such as log levels for each environment. This role can be owned by operations engineer and security engineering while injecting configuration files through proper DevOps process and CI/CD implementation. Configuration consumers are responsible for defining the schema for the configuration that need to be in place and then consuming the configuration values in the application or library code. Configuration store is the underlying store that is leveraged to store the configuration. While this can be a simple file, but it is a distributed application, this need to be a reliable store that can work across environments. And finally, secret store. While you can store configuration and secrets together, it violates our separation of concern principle. So the recommendation is to leverage a separate store for persisting secrets. This enables the operation team to have credentials, certificate, token in one repository and minimize the security risk in case of configuration store get compromised. Let's look at the external configuration store pattern. Many built-in configuration systems read the data when the application starts up and cache the data in memory to provide fast access and minimize the impact on application performance. Depending on the type of backing store used and the latency of this store, it might be helpful to implement a caching mechanism within the external configuration store. This pattern is useful for configuration settings that are shared between multiple application and application instances, or where a standard configuration must be enforced across multiple application and application instances. A standard configuration system that doesn't support all of the required configuration settings, such as storing images or complex data types. So let us look at the benefit of integrating Azure Key Vault with Azure Pipeline. Applications contain many secrets such as connection strings, passwords, certificates, and tokens, which if leaked to unauthorized user can lead to a severe security breach. This can result in serious damage to the reputation of the organization and in compliance issues with different governing bodies. Azure Key Vault allows you to manage your organization's secrets and certificates in a centralized repository. The secrets and keys are further protected by hardware security modules, or known as HSMs, and it also provides versioning of secrets, full traceability, and efficient permission management with access policies. That concludes this lesson. In this episode, we're going to learn about how to manage secrets, tokens, and certificates. So first, learn about how you can use Azure Key Vault to manage secrets, tokens, and certificates. You can use Azure Key Vault to securely store and tightly control access to tokens, passwords, certificates, API keys, and other secrets. Azure Key Vault can also be used as a key management solution, and Azure Key Vault make it easier to create and control the encryption keys used to encrypt your data. And Azure Key Vault is also a service that lets you easily provision and manage and deploy public and private SSL TLS certificates for use with Azure and your internal connected resources. And the secrets and keys can be protected either by a software or FIPS 140-2 Level 2 validated HSMs. You might wonder, why should you use Azure Key Vault? Mainly, it is to centralize application secrets. Your application can securely access the information they need by using URIs that allows them to retrieve specific versions of secret after the application key or secret is stored in Azure Key Vault. This happens without having to write custom code to protect any of the secret information. Let's look at how Azure Key Vault help you securely store secret and keys. The secrets and keys are safeguarded by Azure using industry standard algorithms, key lengths, and hardware security modules. And accessing to the key vault require proper authentication and authorization before a caller can get access. And the authentication establishes the identity of the caller while authorization determines the operations that they have allowed to perform. And how can you use Azure Key Vault to monitor access and use? Once you have created a couple of Key Vault, you will want to monitor how and when your keys and secrets are being accessed. You can do this by enabling logging for Key Vault, and you can configure Azure Key Vault to archive to a storage account, stream to an event hub, and send the logs to Log Analytics. And you have control over your logs, and you may secure them by restricting access, and you may also delete logs that you no longer need. And how does Azure Key Vault help you simplify administration of application secret? So Azure Key Vaults allow you to segregate application secrets. Application may access only the vault that they are allowed to access, and they be limited to only perform specific operations. And you can create an Azure Key Vault per application and restrict the secrets stored in Key Vault to a specific application and team of developers. And finally, you would be able to integrate with other Azure services as well. Let's look into DevOps inner and outer loop. While you can store configuration and secrets together, it violates our separation of concern principle. So the recommendation is to leverage a separate store for persisting secrets. This allows a secure channel for sensitive configuration data such as connection strings. Enable the operations team to have credentials, certificates, and token in one repository and minimizes the security risk in case of configuration store get compromised. This is an example diagram which shows how these roles play together in a DevOps inner loop and outer loop. The inner loop is focused on the developer teams integrating over their solution development. They consume the configuration published by the outer loop. The ops engineer govern the configuration management and push changes into Azure Key Vault and Kubernetes that are further isolated per environment. That concludes this episode. In this episode, we're going to look into Module 6 Knowledge Check. So without wasting any more time, let's get into it. Let's look at the first question. What is OWASP ZAP and how can it be used? OWASP ZAP can be used for penetration testing, and testing can be active or passive. And you can conduct a quick baseline scan to identify vulnerabilities, and you can conduct nightly more intensive scans as well. What are the 5 stages of threat modeling? The 5 stages are: define security requirement, create an application diagram, identify threats, mitigate threats, validate that threats that have been mitigated. Question number 3. Why would you use white source bold? You can use white source bold to automatically detect alerts on vulnerable open source components, outdated libraries, and license compliance issue in your code. What is Azure Key Vault and why would you use it? Azure Key Vault is a cloud key management service which allows you to create, import, store, and maintain keys and secrets used by your cloud applications. The applications have no direct access to the keys, which helps improving the security and control over the stored keys and secrets. You can use the Key Vault to centralize application and configuration secrets and securely store secrets and keys and monitor access and use. That concludes Module 6. In this episode, we're going to learn about managing code quality and security policies. Let's start with understanding how can you manage code quality. There are 5 key traits to measure for higher quality. The first one is reliability. Reliability measures the probability that a system will run without failure over a specific period of operation. It relates to the number of defects and availability of the software. Number of defects can be measured by running a static analysis tool, and software availability can be measured using the mean time between failures. And low defects counts are especially important for developing a reliable code base. Second trait is maintainability. Maintainability measures how easily software can be maintained. It relates to the size, consistency, structure, and complexity of the code base. And ensuring maintainable source code relies on a number of factors such as testability and understandability. You can't use single metric to ensure maintainability. Some metrics you may consider to improve maintainability are the number of stylistic warning and complexity measures. Both automation and human reviewers are essential for developing maintainable code base. The third trait is testability. Testability measures how well the software support testing efforts. It relies on how well you can control, observe, isolate, and automate testing, among other factors. And testability can be measured based on how many test cases you need to find potential faults in the system. And the size and complexity of the software can impact testability as well. So, applying methods at the code level, such as cyclomatic complexity, can help you improve the testability of the component. The fourth trait is portability. Portability measures how usable the same software is in different environments. It relates to platform independency. This isn't a specific measure of portability, but there are several ways you can ensure portable code. It's important to regularly test code on different platforms rather than waiting until the end of the development. It's also a good idea to set your compiler warning levels as high as possible and use at least 2 compilers. Enforcing a coding standard also helps with portability. And the last trait is reusability. Reusability measures whether existing assets, such as code, can be used again. Assets are more easily reused if they have characteristics such as modularity or loose coupling. Reusability can be measured by the number of interdependencies. Running a static analyzer can help you identify these interdependencies. Let's look at the quality metric. While there are various quality metrics, the important 2 metrics are defect metrics and complexity metrics. In defects metrics, you will define the number of defects, and the severity of these defects are important metric of overall quality. Complexity metrics can help in measuring quality. Let's look at some of the common quality related metrics. These are the following list of metrics that directly relate to the quality of both the code being produced, of the build and deployment processes. Failed build percentage gives you overall what percentage of builds are failing. Failed deployment percentage gives you overall what percentages of deployments are failing. Ticket volume defines what is the overall volume of customers or bug tickets. Bug bounce percentage indicates what percentage of customer or bug tickets are being reopened. And unplanned work percentage indicates what percentage of overall work being performed is unplanned. Now let's understand what is technical debt. Technical debt is a term that describes the future cost that will be incurred by choosing an easy solution today instead of using better practices because they would take longer to complete. The term technical debt was chosen for its comparison of financial debt. It's common for people in technical debt to make decisions that seem appropriate or the only option at the time. But in so doing, interest acquires. The more interest that acquires, the harder it is for them in the future and the less options that are available to them later. With financial debt, soon interest acquires on interest, creating a snowball effect. Similarly, technical debt can build up to the point where developers are spending almost all their time sorting out problems and doing rework, either planned or unplanned, rather than adding value. So let's look at some of the sources and impacts of technical debt. First one is lack of coding style and standards, lack of poor design for unit test cases, ignoring or not understanding object oriented design principles, monolithic classes and code libraries, over engineering code, insufficient comments and documentation, not writing self documenting codes, taking shortcuts to meet deadlines, and leaving dead code in place. Please note that over time, technical debt must be paid back. Otherwise, the team's ability to fix issues and to implement new features and enhancement will take longer and longer and eventually become cost prohibitive. To find other code quality tools that are easy to integrate with Azure DevOps, search for the word quality when adding a task into your build pipeline. That concludes this episode. In this episode, we're going to look into Module 7 Knowledge Check. Let's look at the first question. You want to run a penetration test against your application. Which tool could you use? Answer is OWASP SAP. This is designed to run penetration testing against applications. Bolt is used to analyze open source library usage, and the two Sonar products are for code quality and code coverage analysis. What is code smells? Give an example of code smell. Code smells are characteristics in your code that could possibly be a problem. And code smells hit a deeper problem in the design or implementation of the code. For example, code that works but contains many literal values or duplicated code. You are using Azure Repos for your application source code repository, and you want to create an audit of open source libraries that you have used. Which tool could you use? The correct answer is White Source Bolt is used to analyze open source library usage, and OWASP ZAP is designed to run penetration testing against applications. The two Sonar products are for code quality and code coverage analysis. Question number 4. Name 3 attributes of high quality code. The high quality code should have well defined interfaces. It should be clear and easy to read, so self documenting is desirable. Question number 5. You're using Azure Repos for your application source code repository, and you want to perform code quality checks. Which tool could you use? Sonar Cloud is the cloud based version of original Sonar Cube and would be best for working with code in Azure Repos. That concludes this episode. In this episode, we're going to learn about implementing a container build strategy. Let's start with first understanding what are containers and why do you need them. Containers are a solution to the problem of how to get software to run reliably when moved from one computing environment to another. This could be from a developer's laptop to a test environment, from a staging environment into production, and perhaps from a physical machine in a data center to a virtual machine in a private cloud or a public cloud. So, how do containers solve this problem? Put simply, a container consists of an entire runtime environment, an application, plus all the dependencies, libraries, and other binaries and configuration files needed to run it, bundled into one package. By containerizing the application platform and its dependencies, differences in OS distribution and underlying infrastructures are abstracted away. So, what's the difference between containers and virtualization? Containers and VMs are similar in their goals to isolate an application and its dependencies into self-contained unit that can run anywhere. Moreover, containers and VMs remove the need for physical hardware, allowing for more efficient use of computing resources, both in terms of energy consumption and cost effectiveness. The main difference between containers and VMs are in their architectural approach. So let's have a high level look into what is virtual machine before moving into containers. A VM or a virtual machine is essentially an emulation of a real computer that executes programs like a real computer. And VMs run on top of a physical machine using a hypervisor. As you see on this diagram, VMs package up the virtual hardware, a kernel, and user space for each new VM. Now let's look into container. Unlike a virtual machine, which provides hardware virtualization, a container provides operating system level virtualization by abstracting the user space. This example diagram shows you that containers package up just the user space and not the kernel or virtual hardware like VM does. Each container gets its own isolated user space to allow multiple containers to run on a single host machine. And we can see that all the operating system level architecture is being shared across containers. The only part that are created from scratch are bins and libraries. This is what makes containers so lightweight. Now let's understand the Docker containers and how it is going to affect your development. Docker is a software containerization platform with a common tool set, packaging model, and deployment mechanism, which greatly simplifies containerization and distribution of application that can run anywhere. This ubiquitous technology not only simplifies management by offering the same management commands against any host, it also creates a unique opportunity for seamless DevOps. From a developer's desktop to a testing machine to a set of production machines, a Docker image can be created that will deploy identically across any environment in seconds. This is a massive and growing ecosystem of applications packaged in a Docker containers. Let's look into the differences between a microservices and containers. The most immediately lucrative use of containers have been focused on simplifying DevOps with easy developer to test to production flows for services deployed in the cloud or on premises. But there is another fast growing scenario where containers are becoming very compelling. Microservices is an approach to application development where every part of the application is deployed as a fully self contained component called a microservice that can be individually scaled and updated. That concludes this lesson. In this episode, we're going to look into Module 8 Knowledge Check. You are reviewing an existing Docker file. How would you know if it's a multi stage Docker file? The answer is multi-stage Docker files are characterized by containing more than one starting point provided as from instruction. You are designing a multi-stage Docker file. How can one stage refers to another stage within the Docker file? The from clause in a multi-stage Docker file can contain an alias via AS clause. The stages can refer to each other by number or by the alias names. What is the line continuation character in Docker files? The answer is lines can be broken and contained on the next line of a Docker file by using the backslash character. Question number 4. You are using Azure to manage your containers. Which container orchestration styles are supported? The answer is Swarm, DCOS, and AKS are supported. Question number 5. When the Open Container Initiative defined a standard container image file format, which format did they choose as a starting point? The OCI used the Docker format as a starting point. That concludes this episode. In this episode, we're going to learn about designing a release strategy. Let's start with understanding what is traditional IT. A few years ago, IT was a facilitating department. IT was there to support the business users, and because time had proven that developed software that had bad quality by default, software changes were a risk. The resolution for this quality problem was to keep changes under strict control. The department that became responsible for controlling the changes became the IT Pro department. In the past, but also today, The IT Pro department is responsible for the stability of the systems, while the development department is responsible for creating new value. So let's understand what is a silo-based development. Long release cycles, a lot of testing, code freezes, night and weekend work, and lot of work involved ensure that everything works. But the more we change, the more risk it entails. Let us have a look at the silo-based development. If you look at this picture of traditional silo-based value stream, we see bugs and unplanned work, necessary updates, or support work and planned value adding work all added to the backlog of the teams. When everything is planned and the first gate can be opened, everything drops to the next phase. All the work and thus all the value move in piles to the next phase. It moves from plan phase to a realize phase where all the work is developed, tested, and documented, and from here it moves to the release phase. All the value is released at the same time. As a result, the release takes a long time. Now let's look into how you can integrate continuous delivery into this. Now the new scenario is we need to deliver fast and the product we make must be good. And we should do this with our software production being cheap and quality being high. To achieve this, we need something like continuous delivery. We need to move toward a situation where the value is not piled up and released all at once, but where values flow through a pipeline. Just like in this example, a piece of work is like a marble, and only one piece of work can flow through the pipeline at once. So, work has to be prioritized in the right way. So, as you can see, the pipeline has green and red outlets. These are the feedback loops or quality gates that we want to have in the place. And the feedback loop can have different things: a unit test to validate the code, an automated build to validate the sources, an automated test on a test environment, some monitor on a server, usage instrumentation in the code. So now let's understand what is continuous delivery. Continuous delivery or CD is a set of processes, tools, and techniques for the rapid, reliable, and continuous development and delivery of software. This means that continuous delivery goes beyond the release of software through a pipeline. To understand this bit more, look at the 8 principles of continuous delivery. The first one is the process of releasing and deploying software must be repeatable and reliable. Another principle is automate everything. Then, if something is difficult or painful, do it more often and keep everything in source control. And done means released. Another principle is build quality in, and everybody has responsibility for the release process. And finally, improve continuously. And one of the essential steps in moving software more quickly to production is by changing the way we deliver the software to production. In our industry, it is a widespread that we have teams that need to do overtime in the weekend to install and release new software. This is mainly caused by the fact that we have two parts of the release process bolted together. The moment we deploy the new software, we also release new features to the end users. The best way to move your software to production safely while maintaining stability is by separating these two concerns. So we separate deployments from our release. This can also be phrased as separating your functional release from your technical release. Let's look into release and release processes. We start with defining a release process or release pipeline. The release pipeline contains all the steps that you walk through when you move your artifact. The stages can be a development stage, a test stage, or production stage, or just a stage where a specific user can access the application. The release itself is something different. The release is an instance of a release pipeline. You can compare it with object inheritance. In object orientation, a class contains the blueprint of definition of an object, but the object itself is an instance of that blueprint. So how do you measure the quality of the release process? The quality of your release process cannot be measured directly because It is a process. So what can you measure is how good your process work. So if your release process constantly changes, this might be an indication that there is something wrong in the process. If your release constantly fail and you constantly have to update your release process to make it work, it might also be an indication that something is wrong with the release process. So what can you do to keep track of your release process quality? This is by creating visualizations about the quality of all the release following that the same release process or release pipeline. For example, adding a dashboard widget which allows you to show you the status of every release. That concludes this episode. In this video, we're going to look into Module 9 Knowledge Check. This question: would adding a feature flag increase or decrease the cyclomatic complexity of the code? The correct answer is increase. Next question: would adding a feature flag increase or decrease technical debt? Increase. Question number 3: you plan to slowly increase the traffic to a newer version of your site. What type of deployment pattern is this? The correct answer is blue-green. When you want to change an immutable object of any type, what do you do? The correct answer is you make a new one and possibly remove the old one. Question number 5. What can you use to prevent a deployment in Azure DevOps when a security testing tool finds a compliance problem? The answer is release gate. That concludes this episode. In this episode, we're going to look into third-party infrastructure as a code tools available with Azure. First, let's look into Chef. So what is Chef? Chef is an infrastructure automation tool that you can use for deploying, configuring, managing, and ensuring compliance of application and infrastructure. It provides for a consistent deployment and management experience. And Chef helps you to manage your infrastructure in the cloud, on premises, or in a hybrid environment by using instructions to configure nodes. A node or Chef client is any physical or virtual machine, cloud, or network device that is under management by Chef. This is an example diagram of a high-level architecture of Chef. And Chef has 3 main architectural components: Chef Server, Chef Client, and Chef Workstation. Chef Server is a management point. There are 2 options for Chef Server: a hosted solution and an on-premises solution. The second one is Chef Node. This is a Chef agent that resides on servers you are managing. And the third one is Chef Workstation. This is the admin workstation where you create policies and execute management commands. And you can run the knife command from the Chef workstation to manage your infrastructure. Let's understand Chef Automate. You can deploy Chef on a Microsoft Azure from the Azure Marketplace using the Chef Automate image. And Chef Automate is a Chef product that allows you to package and test your application and provision and update your infrastructure. And what is Chef Cookbooks? Chef uses a cookbook to define a set of commands that you execute on your managed client. A cookbook is a set of tasks that you use to configure an application or feature. It defines a scenario and everything required to support that scenario. And within a cookbook, there are a series of recipes which define a set of actions to perform. And cookbooks and recipes are written in the Ruby language. Now let's look into Puppet. So what is Puppet? Puppet is a deployment and configuration management toolset that provides you with enterprise tools that you need to automate an entire lifecycle on your Azure infrastructure. It also provides consistency and transparency into infrastructure changes. And Puppet provides a series of open source configuration management tools and projects. It also provides Puppet Enterprise, which is a configuration management platform that allows you to maintain state in both your infrastructure and application deployments. And the main architectural components of Puppet include Puppet Master, Puppet Agent, Console Services, and Facts. Let's look into how can you deploy Puppet in Azure. Puppet Enterprise is available to install directly into Azure using Azure Marketplace. And the Puppet Enterprise image allows you to manage up to 10 Azure VMs for free, and it is available to use immediately. Another option of creating a Puppet master in Azure is to install Linux VM in Azure and deploy the Puppet Enterprise package manually. Let's look into how can you manifest files. Puppet program files have these following elements: classes, resources, and module. Class is a bucket that you can put resource into. Resources are a single element of your configuration that you can specify parameters for. And module is the collection of all the classes, resources, and other elements of your Puppet program file in a single entity. Now let's understand Ansible. So, what is Ansible? Ansible is an open source platform by Red Hat that automates cloud provisioning, configuration management, and application deployments. Using Ansible, you can provision VMs, containers, and your entire cloud infrastructure. In addition to provisioning and configuring application and their environments, Ansible enables you to automate deployments and configuration of resources in your environment such as virtual network, storage, subnet, and resource groups. And Ansible is designed for multiple tier deployments. Unlike Puppet or Chef, Ansible is agentless, meaning you don't have to install software on a managed machine. Let's look into Ansible components. These are the core components part of Ansible. First is control machine. This is the machine from which the configurations are run. Then we have managed nodes. These are the devices and machines and environments that are being managed. Then we have playbooks. Playbooks are ordered list of tasks that have been saved so you can run them repeatedly in the same order. The last but not the least is modules. And Ansible works by connecting to your nodes and then pushing small programs called modules out of the nodes. So modules are the units of code that define the configuration. Now let's look into Terraform. So what is Terraform? HashiCorp Terraform is an open source tool that allows you to provision, manage, and version cloud infrastructure. It codifies infrastructure in configuration files that describes the topology of cloud resources such as VMs, storage accounts, and networking interfaces. Terraform's command line interface provides a simple mechanism to deploy and version the configuration files to Azure or any other supported cloud service. The CLI also allows you to validate and preview infrastructure changes before you deploy them. And Terraform can also support multi-cloud scenarios. This means it enables developers to use same tools and configuration files to manage infrastructure on multiple cloud platforms. Let's have a look into high-level components used for Terraform. This include configuration files, which is text-based configuration files allow you to define infrastructure and application configuration. Then we have Terraform CLI. This is a command line interface from which you run configurations. Then we have modules. And modules are self-contained packages of Terraform configuration that are managed as a group. That concludes this episode. In this episode, we're going to look into Module 10, Knowledge Check. Let's look into the first question. Which of the following are main architectural components of Chef? The correct answers are Chef Server, Chef Client, and Chef Workstation. Let's look into question number 2. Which of the following are open source products that are integrated into Chef Automate image available from Azure Marketplace? The right answers are Habitat and Inspect. Question number 3. Which of the following are core components of Puppet automation platform? The correct answers are Master, Agent, and Facts. Let's look into question number 4. Complete the following sentence. The main element of a Puppet program PP manifest files are class, resources, and the right answer is module. Question number 5. Which of the following platform use agent to communicate with target machines? The correct answers are Puppet and Chef. Question number 6. True or false? The control machine in Ansible must have Python installed. Is it true or false? Correct answer is true. Question number 7. Which of the following statements about the Cloud Init package are correct? All of the answers are correct answers. In Azure, you can add custom configuration to Linux VM with Cloud Init by appending the custom data parameter. Question number 8. Terraform only supports configuration files with the file extension .tf, which is false. Let's look at the last question. Which of the following core Terraform components can modify Terraform behavior without having to edit the Terraform configuration? The correct answer is overrides. So that completed the lecture-based part of AZ-400. So the next step is I will go and create a lot of lab sessions and walkthroughs on all the things what we have learned on AZ-400. So you can expect those videos to be launched soon. So thank you so much for taking time to watch these videos. I will meet you on the next video. Until then, take care.